Hello everybody. Welcome to the continuation of the stream I started yesterday and then promptly abandoned when people are working on the house and flipping breakers. And to refresh you all on what that actually means, we are adding all the features to the language that we need to complete the 1 billion nested loop iterations benchmark. For no other reason than it pushes me to build out specific parts of the language that I need to do for, like, not an actual use case, but like a simulated workplace. Also, we have white monster, so you know that we're locking in. Alright. Now to remind myself what I was doing before. We're using this test loop here. And right, I believe what I was working on at the time that my power cut out, then I went and just started working on my car all day, was specifically the actual back end. Do I have... Actually, that's a good idea is... Let's look for... problems in the workspace. Okay. This is IR. I guess that would stop. That would stop error checking everywhere else in the project. There we go. Size found you 8. I'll take it. Actually... Man, I wrote all this code without realizing that error checking wasn't working. Okay. So this selected value but found value reference. Interesting. Because this is explicitly saying it's returning a value, not a value reference. Or, oh, it's talking about arguments. Okay. Thought it was too simple when I wrote it, I think, hopefully. Type, native type. Where is emit type? Or JIT type? What's this a member of? What function are we in right now? The JIT backend. Oh, okay. Means we should be able to self JIT type. Oh, I'm blind. It's right there. binding type is available in a different scope in the same function. Did they make that an error? Or not an error, but the warning. They didn't do it for pointer. Oh well. Now we do the same thing for store. Literally the exact same thing for store. I need the native type to store here as well. No! The formatting! It was clean! Pointer type. Yeah, I don't act. Am I point? I don't pass in the value to store into this function. Wait, why is the binding not used? Bindings? Binding? We have the bindings pointer. And you get the page pointer. Wait a second. That binding pointer equal context builder insert. Why Windows? Because when I need to do VR stuff in Unity and a lot of stuff that like and gaming. And I know that you can do a lot of that stuff on Linux, and as soon as Windows 10 reaches end of life, I will be switching to Linux. But for now, Windows 10 is fine. I wouldn't be able to stand Windows 11, but Windows 10 is fine. Is there a version of Addition that adds and multiplies, like an index? Because I don't want to do an iAdd that's also... Because this one, it can just be a regular add. But... Let's see. Is there an command to for indexing? Probably a better LLM question. Oh, hello, LLM. Load effective address. Oh! That's what LEA is for. Okay. Also, hello, Sim. It just finally clicked in my brain what this is for, because, like, in the past, like, I was under the misconception of, like, oh, you use this to get the memory address of, like, a register. But the thing is, registers don't have memory addresses. They're registers, so that makes no sense, and I've known it makes no sense for a while. But no. Okay. Okay. I need crane, lift. Need the docs RS, and then I immediately need to go to IMM. No. Function builder. Insert. Function instruction builder, which is instruction builder. Part of crane left code gen. Okay, that's why I can never find it. Begone, viewer bots. I don't need the best viewers. My viewers are already the best. No. Don't know that if I could handle a greater audience. Like, I've had like 20 people watching at once, and like that's a lot of people to be watching. Memory doesn't have memory address. How's it real? Can you explain to me? Okay, so here. At some point I need to like find Scala draw. But usually when you hear programming explained, you have like, is the total amount of memory that your program can handle. Going down from the top, there's the stack. So, fun fact, when the stack grows, it actually grows downward. So the memory addresses become, like, go down instead of up. And then the stack usually goes upwards from, like, the total amount of space your program has access to, like, memory space. And of course, the heap is more like messy and whatnot, and that's usually like the way people explain memory to you. And you can have a pointer to this, or your functions can have pointers to that. This is all made up, mostly. I mean, you do have the stack. There is a, well, actually no, the stack pointer isn't built into registers. It's the return address of a function, kind of. Anyways, when I say that a value doesn't have a memory address, it's because this is what's in your RAM. This kind of concepts of these two things that kind of don't exist on a computer, but kind of do. Then you have your CPU, and CPUs are register machines. So they have a number of spots in them of each CPU core that can store a value the size of, I think, the largest register on some like research machines are like 518 bits long, but on a 64-bit machine, usually those registers are 64 bits long. That's where like 64-bit machines come from. It also can refer to the 64-bit usually refers to two things. It's both the register size and the usual size of the pointer, because pointers have different sizes. Because 32-bit machines, generally those can only access max 32-bit integer size, unsigned 32-bit integer size worth of memory, whereas 64-bit machines can generally access maximum 64-bit unsigned max value size, which is significantly larger. So like the pointer sizes differ between those two, but also the register sizes, just in general, increase in size. And then whenever you are actually using values, the CPU acts only on registers. These are the only values it can work with. Think of this as your working memory. Now, usually it's like, oh, the RAM is the working memory of the computer. No. The working memory of a computer is the RAM. And then there's like the L1 cache, L2 cache, and L3 cache. And these here are just clones of RAM, and they're abstracted away by the PC, so you don't need to really worry about them. Basically, all you have to think about for the caches on the CPU is that these basically pretend to be the RAM, but they're actually inside the CPU, so they're significantly faster. Because the slowest part of our CPUs right now today is how long it takes for them to access memory. They can actually process much faster than we can give them stuff to process. And that's why entity component systems are like very popular, is because they optimize getting memory in and out of the CPU. So a lot of times they look like they're using a less efficient algorithm, but it can use a less efficient algorithm because they're getting data to the CPU faster, so the CPU can do more operations with the less efficient algorithm because it has more data to work with, because it would get through the efficient algorithms faster, but you wouldn't be able to get the memory to actually complete them. Anyway, weird CPU stuff. And the reason I say these registers don't have memory addresses is because the actual CPU instructions refer to them as just what register they are. You can't have a pointer to a register. a pointer is just a 64-bit integer of like where in the RAM is this value. But a register is like hard-coded into your bitcode. You can't have dynamic register access. It's not possible. Yeah. I guess technically using you could have dynamic register access, but it would be like doing a switch statement in RAM. That wouldn't be very efficient at all. But you could have branching control flow that does conditionally access registers if you really wanted to, but it would be like a virtual machine basically doing that. There's not a CPU command to use pointers as registers, or registers as refer to registers as pointers. Yeah, and what I thought the LEA command was like, basically I've struggled with L values versus R values for a long time. L values versus R values is like things with the values with memory addresses versus values without memory addresses. Registers were memory address stored in the temporary cache. So I get, yes, you can have pointers to the values stored in here, because this is just like if the RAM has like these sets of values, these would just be exact clones of those values. And they're smaller, but the CPU, operating systems and CPUs use things called virtual... I can't remember the exact term for it right now, but even at the OS level, memory is abstracted away, so what you think is the memory address of memory isn't the actual memory address. They redirect where your pointers go, basically, for security reasons, and also for like OS operation stuff. Anyways, if you have a pointer on the CPU to a certain bit of memory, it checks this cache to see if it has that pointer, then it checks this cache to see if it has that pointer, then it checks this cache to see if it has that pointer, and then it waits on RAM to give it the value if it doesn't have all of that. So if you ever hear the term cache miss, it's because a value wasn't in one of these caches. And CPUs have a lot of like ability to try to guess what memory is going to be accessed next, and then tell memory to load the memory addresses it thinks it's going to access before it actually gets to the point where it needs those values. So certain algorithms like ECS, basically any time where you have a giant list and you're just going down the list, the CPU is very good at like saying, hey, I'm just going down this entire list, give me the rest of the list and load that into RAM beforehand. Fun fact, if you ever hear stuff about branches being slow or if statements being slow, that's because it's actually specifically because the CPU tries to access memory before it actually needs it. And the way it does that is it actually runs your code before it has the actual memory that it requires. So let's say you have one if statement here, and the if statement could move execution to execute this block of code or this block of code. What your CPU will do is it will guess, hey, we're probably going to go down this direction of code based on like if I've run this block of code multiple times before, we're probably going to go this way. And then once you actually get the memory, the CPU will go back and say, hey, did I guess correctly which direction we would go down? Yes. Keep the result of running this code beforehand and guessing at the values, because I guessed the values correctly. And then it just stores the result. It's already done all the calculations. But if it didn't guess correctly, it has to go back and recalculate it down the other path. So if you ever hear about if statements being slow, it's because sometimes you can do things without if statements, and the CPU is able to fully calculate that value speculatively. Yeah. All right. But yeah, that is all of that is in 15 minutes more CPU information than anybody can reasonably be expected to learn. I've actually considered doing a while back. I considered doing a video series where I just talked about a bunch of like stuff that you wouldn't usually learn in school, like that I didn't get in any of my college classes, but that are like essential knowledge for being a developer. So stuff like, here's how to use a debugger in most editors, like a step through debugger, because like you barely see anybody using debuggers. They all use print statements, but debuggers are like amazing. I basically learned how C++ works through using a debugger, because I would just look at how it did things and step through the functions and be able to inspect all my memory and stuff, and it was amazing. But yeah, I just don't see a lot of people using debuggers, and it kind of makes me sad because they are amazing and they work really well in Unity and they work really well in C++, the two things that people use the most. And like they just don't use the debugger. You can literally pause the code and then make it go instruction by instruction, and you can see all of the variables. You don't have to put a print statement there to see if it runs. You just like have the program pause if it hits that code, and then you can see what the state of the program is right there. And then if it doesn't hit that code, you can just go like above the if statement you're trying to test. And then when it doesn't run the if statement, you can see why it didn't run the if statement, and you don't have to do any print statement debugging. Anyways, I was planning on doing like a whole YouTube series of like, here are all these different like low-level concepts that you should really know if you're a developer. And then, yeah, just doing all that. Windows NT kernel, that's why it's so lame compared to Linux and Unix. NT kernel. Not really familiar with the term, but probably. That the concept of LEA is handled during the instruction selection and lowering phases, specifically Crane Lift's instruction selector, which has a domain-specific language called IL. It is a rule that can identify patterns in the IR that correspond to instructions that can be efficiently implemented using an LEA instruction. Okay, so I just tell it what I wanted to do, and then it chooses the best instruction for it. Okay, I was worried, like, I'm worried because I know Crane Lift isn't LLVM and doesn't have as many optimization passes. So I was worried about that, but it looks like if I just do bindings pointer equals insert, I add bindings, binding. But then we also have the bindings offset, which is context builder insert imol immediate. So we need to basically wait. I'm already doing this, but for the offset, I don't want to do this for the offset. We want to do this for the binding, because the offset should be 2 specific bytes. Whereas the binding offset is the thing that's being indexed into an array of pointers, which is the reason why we're doing this by pointer bytes. And then we load this from this is our binding pointer, so this is the pointer to our specific stack page, and then this is the actual pointer to that stack page. And then we add the offset of this pointer to the current stack page. Yeah. Have you ever tried to build text-based search engine? I have not ever tried to make a... I've never tried to make a vector database search. I've tried trying to figure out, like, text-based search, but only for, like, database API calls with, like, MongoDB. So, you know, you just pass the correct flags to the operation, and then it handles everything for you. Here, instead of load, we do store. And then the actual value to store is value. Oh, we don't need the type, okay. Okay, and we do need the offset. Do I keep the type there just to be safe? Right, and store does not return a value. Custom language? Indeed. Custom language and runtime. JIT-compiled runtime. Alright, and I can revert my IR to not actually contain type on a store operation, which... I mean, I can see... Well, I mean, on the LLVM backend, I didn't need that either, so those are the only 2 backends that I'm targeting, is CraneLeft and LLVM. So, yeah. So here, says this operation does not actually return a value, return none. Then I think signed remainder was the only other one we needed to actually execute this program. So let's do srem, signed remainder. And we're gonna copy compare greater than, which I need to make the comparison commands more type specific. Because apparently crane lift comparisons are integer floating point specific. Actually, out of curiosity, is there an F compare? Yes. So the commands just need to be integer versus floating point specific in the bytecode. So left, right, and then we want to do I does oh, there it is. It's right there. SRAM. Okay, so it is directly just called SRAM. Did I copy that from CraneLift? I might have copied that from CraneLift. We can actually go and just implement the rest of these. Because it's literally one. Do they have floating point remainder? They don't have floating point remainder. Which LVM does have. Surprisingly enough, but yeah, if it's not a common feature between a lot of bytecodes, then I think I copied UREM and SREM from WASM. Maybe float remainder was part of WASM too, but if that's not a common command, then we're not going to emulate it. Okay. Do I want to do unsigned or signed? Since it's unknown data, I think unsigned works better. Okay, now we have a runtime. I believe that's all the problems in the document. So now that we have memory binding support back into the actual runtime, we can go back to our front end. And implement the intrinsics that we need. Let's see, emit. Oh, here we are. We're already on it. Emit callable. I need a better interface for this. Because this is a lot of boilerplate to just say, like, hey, this one word function is equal to this binary operator. And then also, like, it would be a lot of would also be a fair amount of work to, like, properly error check it and everything. So do I abstract this at this point? I think I should. Do I include template arguments in that? I think I should as well. So let's do public. And honestly, this could be a this could be a global static. Man, I wish you could do complex data structures as global statics. And not necessarily have them be lazy loaded. That's kind of what you have to do, though. Yeah, it makes sense to have this as a global static. Okay. So we have... basically just binary and unary operators. I don't know if we need to... if we need to restrict it to just that. It's like... then again, I need to have an override system where whenever we define functions, we add them to the list of possible overrides. How do we want to do function lookup? Do we want it to be specific to this module context, to be like, what functions do we currently have in scope? Because eventually we will be searching through other modules, right? I think we'll do module context. For now, because it makes sense to have all of the functions you can search through in the current module context, or rather, have a list of all the identifiers currently in scope. And I'm gonna put it right here. So public struct ident scope. And this is gonna have two different types. It's going, well, 4 different things. So pub we're gonna have subscopes, which is going to be a hash map of string to ident scope. Then we're gonna have types. Which is a hash map to the current to an intermediate representation type. Then the last thing is functions. Because I don't think we're doing templating for pipelines, but we are doing templating for functions. At least that's my vibe right now. Like, we can have templated types in the pipeline, but not... We can't have IR types here. We cannot have IR types here, because what this needs to be is well, it needs to be a template, basically. It needs to be a... Yeah, it needs to be a template, and then we can pass in template args. And if it doesn't have any template args, then, you know, then it's fine. We don't need to template anything. It can be a template with no arguments. So we have a type template. Then we also have functions within this scope. And the functions, this needs to be a vector of... function templates. The thing I wonder is, do we store ASTs in here? I think we do. Since we're doing like the whole single pass compiler thing, it makes sense that, or rather, we're not doing multiple passes over the data to transform them into different types. We go directly from the AST straight to the intermediate representation. And then, like, I do have one singular optimization pass on the intermediate representation right now, because that optimization pass is required to make it even runnable. Maybe. I might not actually have needed to make that, because it turns out my FI node implementation was broken, and then when I fixed that, there's also other things with the FI node implementation, like I might be able to make the default jump of jump statements go directly to the next block instead of to an intermediate empty block now that the FI nodes are actually working. Many potential optimizations. To our binary size, basically, I think Craneleft should be able to optimize. Whatchamacallit. Sorry, I'm responding to messages over here on this computer. Okay. Back to this. It's so funny. Me, I need to add 3 more intrinsic functions. Time to refactor the entire how we do functions. Because, oh no, there's a template argument. Oh no. Even though I could just follow along with the same thing that I was doing before, but and it would have worked fine. But now I'm locked in. So I'm preemptively setting up template IDs are just going to be usize. And the entire point of template ID is going to be IR type for type instances. And for function instances, this will be not IR function, but I kind of want to make a custom type in the IR that is just hub type struct ID enum ID, because these are all like indexes, but I want the types themselves to like self-document what functions do. And the reason why these are signed is because if you're importing something external, negative indexes is how you say like this is not from the module. So -1 would be index 0 of imports, basically. Or what I could do is negative max value is the first import. That way it's just, instead of shifting one index and inverting them, then I could just add half of max value of integer to it, and then immediately get just an indexable array. That might be cleaner. But still, the point stands, if it's a negative value, it's an import. I'm using Rust now. I don't need to do this weird negative versus positive thing. I still think it's cleaner, though. Since this is supposed to be a serializable format, I think weirdness like that still makes sense. Even though I could abstract it so it's only the, yeah. Let's see, get... Do I update these? Yeah, I update these. That's surprisingly unpainful. I really do need to actually dereference the borrow. Which is I really like how explicit Rust makes you have to be about everything, but sometimes I'm like, come on, why can't you automatically dereference a copy value? Because like it's auto like clones it because it has like the copy trait. And if like you're able to auto copy it into, well, okay. In instances where you want a mutable reference to something, actually no, with mutable reference you could just go like doesn't live long enough. Well, then again, I like it when I don't get the long. Dang it, I'm too developer brained. I can't, or language developer brained. I can't complain about stuff naively. I actually understand why it can't be made easily. If you always want it to be exactly clear what's going on, you always have to say exactly what's going on. Okay, and that fully brings it over, and now we go back to type template. Now, in function instances, I can say function ir function ID. Yippee! That is super clean. And basically, we use these to memorize template instantiation. Eventually, we'll add pipelines into ident scope as well. Struct type template. And we're going to have definition be it might be as easy as just saying that the definition is equal to AST struct do I want to make this an enum? Functions does need to be its own separate thing because we can have function overrides. You might even be able to have pipeline overrides. Like, pipeline overrides might make sense. It's not templated pipelines. Actually, templated pipelines might make sense. As long as we can't export templated pipelines. We're gonna have an identifier scope with these definitions. And they're going to have a public enum. Doesn't even need to be public, but I just put pub on everything. Public enum. And we'll have this be template. And template is going to have we're going to have a struct template. We're going to have a num template. Function overrides. Can you refer any good documentation to read in low-level system engineering? Unfortunately not. I have not interacted too much with it depends on what you mean by low-level system engineering. If by that you mean operating systems and whatnot, I'm really not sure. The majority of stuff I've picked up has been, I want to make a JIT compiled scripting language. I am going to make a JIT compiled scripting language, and then just like going for it. And I have learned most of what I know about low-level systems by just attempting to do that, but also being just interested in the subject and picking stuff up as I go along. I haven't really done any dedicated research. Everything I learn, the vast majority of everything I learn isn't from researching stuff. It's from, I want to do this thing, so I just do it and learn what I need to along the way. And I do like try to research like pitfalls, but I don't necessarily like get a book on it. For kernel, so if I wanted to learn how to do kernel development, here's what I would do. One of two things. I would either set up a virtual machine and then figure out how to write code that executes in that virtual machine. So you could choose choose a CPU architecture, maybe like an old like DOS CPU or like one of the older chips that is like really easy to output graphics, and you didn't actually need to use like a graphics card API and whatnot, because graphics APIs are a pain. So I'd either do that and choose an old CPU that you don't need to know a ton to output graphics, or I would get a Raspberry Pi and make a kernel for a Raspberry Pi. That's something that I've actually attempted, is making a kernel for Raspberry Pi. I got the light to blink on it, but not much further than that, because I had no clue what like, do I write the entire thing in assembly? Because that's what I did, is I got like a blinking light working using assembly code that I wrote to like an SD card and plugged it into the Raspberry Pi. The hard part about that is you can't really debug code. This is not like a sandbox on your computer, so at this stage I'd probably go the virtual machine route so I can debug it. Currently working on 32-bit Arch. Okay, yeah. I'd probably just like virtual machine and then go for it. Listen to talks from like kernel developers, or yeah. I don't really have any books or resources. I would just go for it. Choose a list of features, try to figure out how to do that list of features. So the reason why I'm doing it like this because everything's gonna have a template ID. But at this point, the only thing templates are just the AST for that thing. But when evaluating these to create them, we might need to store the scope. Well, we already know the scope they're in because of this ident scope. I don't know. There are really few people working in kernel development, and I don't know any. Yeah. It's a very, very niche thing. And the vast majority that actually have the time to do it are probably employed doing it. That, or they like make drivers for Linux in their spare time. People with those skills are usually employed. They better be employed if they have those skills, or nobody wants to work with them. Okay, so we have... We have a data structure here. I'm worried that it will require copying parts of the AST. Like a fair amount, like a lot of AST copying, one AST copy per module. But this is for templates. So maybe eventually, if we're importing stuff, template can become an enum of like a definition or an import. We have the ident scopes. So we're gonna just say the namespace, root namespace of this module, then ident scope, and that's it. Now, when we initialize the module, we need to create a new ident scope, and when we create the ident scope, we put in a bunch of templates. Namespace is different because... well, not really. tons of default, and then what we want to do is make a function to populate intrinsics and pass in module context Actually, I'm going to make this a new file. This is going to be just populate. This is going to take in a mutable reference to intrinsics. So here I'm gonna say intrinsics populate, just like that. Then in here, this is super ident scope. And then here we do... Here we can make a bunch of utility functions without worrying about it messing up our giant mono file, or monolithic file. So we have like binary operator. And like unary operator. And those are really the only two types of intrinsics that we need to create helper functions for. And if we... I'm just thinking, for function overrides. We need some way for this to either be an actual function definition or something produced by a closure. So I'm going to have this be function override, and this is either a function from an AST, or this is an intrinsic and this intrinsic accepts actually, I use intrinsic function in multiple places, so maybe I can just use the same definition for both, because callable returns this intrinsic function. I need to figure out how jump marks work. You're going to have an intrinsic function, and this is going to expect exact values. So maybe it won't accept exact values. So we need to add to intrinsic function or this intrinsic function definition. We're going to have function override kind. We're going to have intrinsic function. Intrinsic function will take in not a vector of R value, but a reference to R values. And a reference to IR type. And I'm gonna say this is callback for generating. Callback sig for directly generating IR instead of calling args our template types. Template types, arguments, and finally, context returns. Yeah. That's cool. It tells me the size of this. Okay, so we have a function override kind. You have template kind. And we have public function override, which we need a way to select different function overrides. Let me just see if there's one source. Hello. Let me just see if there's one source that can explain how template selection works in C++. Yeah, I know it's most appropriate function, but how? The C++ compiler selects like I don't need beginner, I need like no, I don't need to know how virtual functions work. Okay, here we go. This is what we want. Oh, I forgot about this. Is this pass only by value? So this is pass by reference. This is explicitly must be an R value, I think. Yeah. So one of these explicitly specifies that it must be by reference, and then this is constant reference, and then this is by R value, so by absolutely by value. So this is the default in Rust, is this. And then normally, if you don't put this there, you would try to copy something instead. Yeah, move semantics in C++ are kind of cooked. They're kind of like very all over the place. And I actually triggered Google's little hiring process minigame that they have embedded in every browser by searching for C++ move semantics. And there's like a hidden minigame in Chromium that literally starts you on the Google hiring process if you do enough developer related searches. And the way that I triggered that was by searching C++ move semantics. And then Google's foobar hiring process popped up. It was pretty funny. Then I went through it and I got stuck because I don't leak code. Because there's a bunch of leak code questions that you do through a command prompt. It was really cool though. Like 10 out of 10. Very cool. Yeah, look up Google foobar for more information on that. trying to decide. Because I don't really care about how it selects which override is valid. That's really easy to like. Can I call this operator with these arguments? Yes, no. Go down the list. But ambiguity is how I'm not sure how to solve. Hello. Maybe I can just enforce no ambiguity. Start it strict and then make it more loose as you go along. Because I'm not sure I want to write the code to enforce strictness right now. If that makes sense. It's kind of like a laziness, like, don't really want to do the validation, so it's actually easier to make it less strict in the beginning, and then make it more strict as I go on, which is kind of the route I'm taking right now. But I guess for now, we need to do exact matches. And we can just... What I'm going to do is not care about ambiguity. I'm sorry. There's going to be like weird bugs where you expect one function to be called and then a different one is called and there's not an error thrown. But to start out, we're going to have function overrides, and this function arg has template args. We're going to say type pattern, and the different type pattern, then this has to be at least partial equal. Perfect is the enemy of dumb, after all. True, but it's also the enemy of code compiling, or imperfect is the enemy of consistent code compilation. And I'm going to have two type of patterns here. Any and exact. And this is going to be an IR type. Do I have partial equal? I do. In fact, I have equal. In fact, this doesn't need partial equal because we want to directly compare, like, pattern, like, matching. Do I want to do type pattern here? So we can have this type pattern. And the type pattern can reference template arguments. And now we're going to have to check to make sure that our type pattern isn't recursive. But it's fine. So this is our function override. These are basically our signature of arguments, and then public kind function override kind. So we treat both template functions and function override kinds exactly the same. And dang it. I have no clue how to choose between two different function definitions when both would work. Or maybe I just throw an error that there's ambiguity. Well, if two definitions work, what I'd ideally do is choose the more specified version, because I can see situations where you have a template, but you have a more defined version of the template, if that makes sense. Because right here in my template args pattern, I'm like, in the case of like slice I32, that I32 here, in that particular instance, this is a wildcard. This could be anything. So this is like less specified than maybe if I made add a templated function. If I made add a templated function, then like I could have intrinsic overrides of that are exactly I32 and I32. And I'd want that to always get chosen over a version with two wildcards, because I could want to define specifically, like, I guess that technically wouldn't be ambiguous, because I would have, like, a system for making it not ambiguous. But yeah, I should throw an error, but I'm not sure how to make it, how I want to implement it not being ambiguous at the moment. Many algorithms, and I don't technically need it yet. Roll a dice. Non-deterministic compilation. Let's go. Random seed the compiler. True, but then like tiny code changes it'd be like doing a hash where like changing one small bit of the hash completely changes the hash instead of having it off by like a couple values or whatever. Brane script research chaos theory. Indeed. Okay. Now just gotta lock in and get this working. I think this is all the type structure I need. And now, when we go... emit callable. I basically want to yoink all of these that I currently have. Throw these in here. Oh, thank you for the subscription. That is much appreciated. Thank you. Unary operators. I guess before I make specific operations like that, let's just figure out how we do the non-abstracted versions of things. So if you want to implement the add operation, what we should do is... it's like the user should be able to add new overrides of add, but this is populate is the first thing that's run on an ident scope, so I guess we should assume that it is empty. Maybe. Root defs get mutable, or rather insert. We should insert add, and add is a template. We also need a template ID count. I'm gonna say, give me a yeah, it's not gonna use super on the auto imports. Actually, no, not template count plus. This doesn't work because we want we can't memoize template instantiations by their identifier, because we also need to memoize them by their arguments. Can we memoize purely on template arguments, or do we have to memoize on both argument types and template argument types? Or maybe just by function override? We do a pass, grab all the definitions, as I'm planning to do before actually emitting code. That means that we shouldn't increase the number of overrides we have. So we should be able to memoize and maybe we just don't have template kind. We just have template. And then this has a template ID. This has a template ID. Override. Now this has a template ID. Now we don't have to worry about one-to-one relationships between a definition and its instantiations. Well, we do, but two identifiers. Yeah, I can't speak. It'll work. It'll work. I think maybe. Yeah. It maybe work probably. Okay, so now we just do template. Function. Okay, yeah, we're making a helper function for this. At least a not very abstracted one first. We're gonna say function this actually this is an ident scope one. Public function insert override. And identifier will equal implement into string. And then this needs to be a function override. Oh, and then this needs mutable reference to self. So we just equal if let defs. What editors this? This is NeoVim inside a Windows PowerShell. We have some temp inside of self defs get mutable self-defs insert identifier. Then we want to do template function vector of 1, which is function override. And then here, can you tell me any good source to learn Rust? Any good source? I know there are a couple YouTube channels that I like purely for Rust propaganda, but they don't necessarily teach you how to use Rust. Again, I can't really tell you because I don't really learn from documentation or like tutorials at this point. I'm at a point where I just jump in and try to do stuff and then learn while doing stuff. And the Rust book is a good source. I've heard a lot of people say that. So Rust themselves have a public website called the Rust book, and it just explains every aspect of Rust. So that's like that's the default advice. The other good way to learn Rust is to learn C++ and then switch to Rust and go, oh my, why is C++ not exactly like how Rust is? Because Rust solves 90% of C++'s problems. If you like C++, you will probably love Rust. Because that's how I went about it. Because I had been like working on a scripting language and learning how move semantics work. And getting really deep into how move semantics work. because I was basically copying how C++ did move semantics for my scripting language, because like, oh, now this type needs, like, if I'm interfacing with this system, this type needs, you know, a defined, like, copy constructor or move constructor, all of these different things. And then I saw how Rust did stuff, and I was like, oh, this is so much better. And now I'm back to making it kind of C style, but I'm not gonna make it C++ style. Hell no. We're gonna stick to like Rust style move semantics, because affine type style move semantics are so much more understandable than whatever C++ has got going on. So you really need to check if then here, I'm just gonna put OK after the if statements. Overrides, push. Function override. And then I'm just gonna put a to do. Or just a comment. Maybe check for ambiguity here. Do people prefer to write driver code in Rust rather than C or C++? I think they prefer to write it in C most of the time. C is the standard. Recently, Linux has started letting people write drivers in Rust. When people say that there's Rust in the Linux kernel, it's mostly that drivers are being written in Rust, not that the actual kernel of Linux is being rewritten in Rust. It's mostly just drivers. And there's like some controversy around that. I would say go with what you want, but Rust is like, obviously you have less, it's not going to crash because you get a null pointer error. So I think going forward we'll see a lot more drivers written in Rust, but people are stubborn, don't like change, so they're going to hold on to not doing Rust. And there's like some slight concerns with doing stuff in Rust because like Rust isn't as decentralized as C is. C is forever. There's multiple implementations of C, and what that means is there's not one C compiler. There's multiple C compilers, and the language itself isn't controlled by one organization. So there's like slight concerns for like a super long-lived project like Linux. If like, what if Rust dies? Which isn't likely at this point, But if it does, then like there's the one implementation of the Rust compiler at the moment. What you really want to see is at least 2 implementations of a compiler for a language if you want like a project that will live absolutely forever. I'm not too worried about that. I'm not that level of schizo. So like I want this project to live indefinitely, but I'm still using Rust in spite of those concerns just because it's such a more ergonomic experience. Worst case scenario, I just fork Rust. Or make it so I can statically compile BraneScript into a binary, and then we use BraneScript to write the entire engine. If Rust explodes, we rewrite the entire engine in BraneScript. So over here, we do root insert override for add, and then this will be maybe this is where we make our helper function for. Let's just see what this looks like first. Template, not template. This is a function override. So we do template count. Template args is. Now, what we could potentially do here is allow the second argument of this template what we could do is allow the second argument of this template, or of this function, to be a template. That way you could add 2 different types, and it would auto-cast the second one. Or we could take the Rust route of you always needing to cast. Now, with game devs, it's probably fine if we cast the second argument. Actually, wait, no. With Rust, I think it does do auto-casting for, like, addition. Maybe. All I know is that if you look at the actual addition, so if I say let sum equal 1 plus 1, if I look at the actual, oh, that's a macro. Yeah, add for t, output equals t, self other. Okay, yeah, no. They are not doing traits for this. Now, here's the add trait, right hand side, equals self by different. Self. Oh, okay. So they let you implement add for types other than self, but the types always have to be defined. So the Rust implementation isn't like, this is a template argument. So I'm just straight up overthinking this. No template arguments. Maybe eventually we do template arguments, but no template arguments for now. Since I don't need to do a trace system. I actually have function overrides and templates. Templates plus function overrides. So archetypes are our exact types are type pattern, exact, and then IR type, and then I want to do IR and then we want to do a second one of these. And then the kind of this function is going to be override kind, intrinsic, and then here's where I would put the closure for, in this particular instance, I32 add. Which in this particular instance, I don't need to pattern match on the arguments since I already know what they are, because I've specified that specifically. So we can just do ignore template arguments, args. Can I pattern match my arguments? This is a slice. I bet you can only destructure, you can't do anything that's a conditional destructure. So we're gonna say let left, right, equals args, else I guess I am still type checking this to some extent. Type annotations needed, args, intrinsic function. This needs to be reference counted. Expected to take 3 arguments, but it takes 2. Right, it needs to take context as well. Cannot bail. found R value. I want this to be R value value. So technically this should be unreachable. No. Assert. So I think this is just an assertion. Yeah, this panics if we reach here. So this is what I want to do. Boom. Match statements are so clean. Love them. Okay, and this is what a single adding an insert looks like. And we can make this significantly simpler. What we are doing right now is refactoring the front end to handle function overrides and intrinsics properly. That way we can add... I'm basically doing the nested billion loop iterations benchmark, and I'm upgrading the language to actually be able to support it. So that means stuff like being able to actually reference and dereference pointers, like actual pointer operation stuff, actually able to deal with slices, and yeah, being able to deal with templated functions, templated intrinsics, all that sort of fun stuff. So just like a good bit more polish and actually make a scripting language be able to access memory, because currently it doesn't access any memory. It has 0 pointers. Everything is register based and Stack Overflow based, but represented when I tell the compiler to do it only in registers, and then it doesn't listen because it can't. Let's see. we're going to say intrinsic operator. You want to do template arguments? So arg types I know will always have to be, they should always have to be exact. So let's say temp args is equal to implement iterator item is equal to type pattern, and then this needs to be a function, and then for our arg types we want these to be, do they need to be IR native? I think yes, they do need it. For maximum ease of use, they need to be IR native, so we're going to say reference slice of IR native type. Actually, since I am just throwing those in by value, a vector would probably be fine. We could do an iterator. And you don't need to be this fancy doing type definitions. It's just when you want to do a lot of effort up front to have to do like zero effort afterwards. Then after we have both of those, we want to also do callback is equal to this. This plus static and now we have to do anyhow error or result. Hello. So now we just copy this whole deal here and fill in, we need we'll also handle template count as well. Then template args is going to be equal to template args into iterator collect template args is going to be equal to arg types into iterator, map, from type to UI pattern, exact, IR type, native, type, collect, and then for actual function override, here we do callback. And then all of that boilerplate, we don't have to do it anymore. That is a lot of boilerplate we don't have to do. So this whole deal here, I'm going to copy and paste so we can compare the two different versions. So instead of doing this, we do intrinsic operator, template args, I might be able to do just unit like that. No. You can't have a tuple of absolutely nothing. Or maybe? Iterator is not implemented for that. Let's do vec then. Empty vector. Actually, since it's by value, can I pass slices by value? Looks like I might be able to. Yes, I can pass slices by value. That is clean. Okay. So then this is IR native type. Native type I32, IR native type I32. And then we just pass in template count, and then in here we put this function. There we go. And that is, between the two of these, which one is cleaner? Very obviously, this one. However, this would be cleaner as a template. I'm just thinking if there's a way to quickly define this for a lot of IR types. and I might be able to define this, for a lot of native types. If I simply make another helper function for binary operators, define op for types, define a binary operator for types equals implement into iterator item equals ir native type Gonna call this type. Actually, no. We don't accept the callback. We accept a... Dang it, we don't have an IR binary operator as like an actual like binary operator thing. We have it as... If we had the IR binary operator as its own... Like, if we had structured this... So instead of all these binary operators being separate enums, if they were just like an enum, one singular enum value, like a binary, and we called this left value, right value, and then operator, and had this be a bin op, we could handle all of these cases with very similar logic. And this would make my logic simpler in a lot of places. So I think I'm actually going to do that. Even though I'm going to have to refactor so much stuff because I just did that. Public bin op. And then... How many is this? Actually, I'm just going to... And now, while I'm at it, I'm actually going to change up comparison operations so that they are type specific. So we're gonna say pub enum compare type, and in compare type we're gonna have equal, not equal, greater than, and greater equal. Because that's all we realistically need. And then in here, we're going to have, instead of this, we're going to have I compare. Compare type. And F compare, compare type. And wow, there's a lot less, this is a lot simpler structure. So we also need a unary. Integer negate, float negate, and I think alloc also counts. Instead of having alloc, we have unary, just op, unary op, and value. This is optimal structuring. Absolute optimal structuring. Now what we're going to do next is what? Oh, it's because I need to select it first. I'm dumb. Refactor this to the new definitions of for the new definitions of operators. Define new display Wait, traits for unary, binary, and compare enums, the new, and then use them when updating this function. So let's see how... Oh. Now it'll work. Maybe. It does not look like it's working. So now it should work. Yeah, there's our GPU usage. And we'll see how well GPT OSS does at doing the busy work that I don't want to do. I wish there was a way to see when I do the edit selected block what's going on behind the scenes, because with the Avante Ask view I get to see all of its thought process over here and if tool calls are succeeding versus failing, all that good stuff. But this, like, going crazy and then leveling out means that I think it's to the point where it's like actually thinking. Memory usage has flattened out, so like I think we're doing stuff. Oh, here we go. I don't like it that it did an underscore for that, but that's fine. There we go. That's a lot of busy work that honestly would have taken longer than that for me to do manually, so that's a win. As long as it's consistent at least. Yeah. I mean, what I can do is just go through and delete this like that. And boom. Done. Man, is this a lot cleaner. I've been thinking about doing this for a while because I originally wrote the intermediate representation for this language when I was still writing the language back in C++, so it is not rustified. This is rustified. This version of it is rustified. So now I have to go back to the compiler and the runtime to define these correctly. But I think we can go back to intrinsics, and I'm gonna finish the abstraction that I wanted to do that for. Can it really be when it's covered in Rust? This is true. Didn't even drop your production database? I need to watch that show. Because I watch that show and I go, accurate. Having worked in startups, I just go, accurate. But what show? I forget what it's called. I think it's just called Silicon Valley is the name of the show. And it's about startups in Silicon Valley. And the absolute madness that ensues when you're in Silicon Valley. Now, I haven't actually gone and been in Silicon Valley, but I have worked with a fair number of Silicon Valley people. Silicon Valley startup people, to be precise. And interact with Silicon Valley people on a regular basis, so. They're Silicon Valley people. Okay, what was I doing? Defining binary operators. And yes, now I can do IR binary operator. And actually specify the binary operator that I want to implement for all of these types. And that's it. And I can make it that easy. I can literally make it that easily. Wow. Okay. And then we just do for type in types. I don't think you even need to do into iterator. It's just implicitly called by defined types. And then we can do intrinsic operator, or rather we do need to add in the ident scope. And I guess we do need to implement the ident as well. Mixing somewhere in eastern US referred to as Silicon Forest. I wonder how similar difference it would be to Silicon Valley. There's like a fair bit of culture difference between startups based in different areas. I was having a conversation with a investor, and he was talking about how like there's like 4 different investment styles. There's like the investors that you meet up in like New York City, like that area, and those guys are all like finance bros. You know, like there's a stock exchange up there, people in suits, very formal. You have Silicon Valley guys who like, those are your YC bros, your Y16Z, the people who think they are that they're living in a movie, basically, and saving the world or taking over the world, and they haven't decided which one yet. You're like Peter Thiel types. And then there's like your Texas area ones, which I can't remember exactly what the vibe of the Texas area ones were. But then you did also have like your eastern ones, which is like your Florida area ones, and those ones are kind of like they're significantly more chill and kind of just like a get to know you style investor. Like invest into the person sort of deal, which most investors are a invest into the person sort of deal. Like that's common between the eastern and western ones. Peter Thiel definitely seems like he knows he's destroying the world. I don't think he's admitted it to himself yet, or at least he doesn't structure it that way in the brain. Nobody's the bad guy in their own brain, if that makes sense. And even if like they say like if they say those words, they don't think that they're being immoral, if that makes sense, or for their version of morality. You might think destroying the world isn't immoral, is what I'm trying to say. There's no way that he's unaware. There's no way that he's unaware of what he's doing. This is true. For type in types, we want to do root insert override. Some want to be Superman, but most want to be Lex Luthor. Some don't really care what they are as long as they get fame. Want ident clone, and then we want to do intrinsic operator, and then we want to do type. These both need to be clone. Clone, and then we also need to pass in the template count into this monster. Oh, I want that. Ooh, that's some thunder. Then we want template count, and then we want, finally, the actual closure, which is going to be move explicitly. And in this function, we are going to do this here. Do I want to type check the types too? I believe so, yes. Actually, I'm just going to do an assert, because this is an assert thing. Assert equal type and L type and R type. And then here we do binary, operator, and then op. We need to clone that so it doesn't complain about it being moved. Benchmark isn't done yet, but we are getting close relatively to being able to do it. Imagine Silicon Valley living in a movie mentality in VR with virtual cameras flying around them all the time. Imagine it make it reinforced. Possibly. Operator cannot move out of operator captured in a function closure. Actually, operator should be... binary operator should be a clone value. Or not a clone copy, not a clone copy. Binary operator should be a copy deriving value. Where is it? Here it is. Then we also need unary operator wherever it is. Clone copy, compare type, clone, copy. It's small enough to be able to implement copy. And just like that, we can implement every binary operator as an intrinsic really quickly. So instead of having to deal with this whole mess that we were doing before, look at this madness. Instead, we can just do define op4 bin op4. Actually, and since type is clone, say this be a reference to IR native type. That way it doesn't have to be... Why is this complaining? Now it's complaining about type, that's fine. Cannot move out of type, but just behind a shared reference. Ah. So if I say let ints equal this is going to take a while. We're just gonna do that. And then... boom. Hear about the recent anime where Lovecraftian beings interacting with humans through VR. Yeah, it probably would have terrified him. That man was very good at writing scared because he was scared. Scared of the other. What's the name of the anime? I'm kind of interested in watching that. I very much enjoy watching the VR related animes. Okay, let's deal with the massive argument count. Okay, so first is the ident. So this is going to be add for ints. Types, and then the binary operator, IR, binary op, and then this is I add. Then we need template count and root. Boom. And then we just implemented all of our binary operators for every single type, just like that. Economico and Cosmic Horror Show. I don't think it was a given how well horror would do in VR. Horror does so good in VR. To the point where I would play a horror video game, but I would not intentionally play a horror VR game. Okay, I have that saved. I'll look into watching it. So then we're gonna have floats equal F64, which we're gonna pull out of the ints list, and F32, which we're also gonna pull out of the ints list. We're also going to pull Boolean out of the ints list, because it doesn't make sense to implement add for Boolean. Then you also need to implement unsigned. And also signed. Now we can do add for floats. And we can delete this. Basically all of this. We can delete all of it. It's gone. Do we need unsigned versus signed multiple? No, we don't. This is the cleanest I've ever done something like this. And I am super proud of this. And then we need signed. So this is s div. The floor shook with that one, wow. Add, sub, multiply, divide. And then, do we want to do another one that is comparison? I think we do. So we're gonna have this be define, compare op for, and I'm actually gonna swap the position of ident and types because I like it being like define this for these types. Yup. This one isn't as clean. I might go back. Yeah, the other one looked a lot cleaner. Because, like, this is all, like, all the operator names are aligned, and I like that more. What programming language should you start with? What are your thoughts on Mojo? I'm not quite sure what you mean by which programming language should I start with. There are many different answers to that. There are many different questions. Also, hello Twitch chat. How's it going? To do both. What are your thoughts on Mojo? Like a Mojo programming language? None right off the bat because I am unaware of it, unless this is the one language that one guy on Twitter was making that could do Pythonic language. Bro. I'm not a huge fan of Python. I use Python for utility scripts, so that has... It's probably statically typed because it has to go on the GPU. But I very much like the idea of a language that works the same both on the CPU and the GPU. I've seen a fair number of those popping up recently, and I am like a big fan of that. Combines the best of C++, Rust, and CUDA. Pythonic. This is Pythonic. Ugh, hey, AI. Ugh. 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 Just don't have an image there. If you're gonna use AI for it, just don't have an image there. Especially if this is like GPU. Maybe have like a cool like crappy GPU render, because those always look clean. They love their AI images. Okay. Struct add one. I am not a fan of at syntax. I don't know why. It doesn't look good to me. But it's probably fine. It's probably like I haven't interacted with at syntax a ton. But I know it's like a functional programming thing. Like, functional programming likes their at syntax. And I know some TypeScript stuff uses at syntax as well. Are they using Python in their Docusaurus because mermaid diagram, or not mermaid diagrams, but the code blocks already support it? No, they have Mojo here, which means you dispatch this from Python, which I'm not a fan of. But I guess it makes sense that they would be like, you write this as a compute language and then it's getting dispatched from a... Yeah, here's essentially your kernel, and it's dispatched to both the CPU and GPU from that language. I guess that makes sense. Still coding in Python, because it's basic. Interrupt with Python's supposed to be C, C++ like. Okay. So, basically, I really like what it's doing. I don't like the interface, but I really like what it's doing. And that's about as much as an opinion I can have on that. And it's a very, like, basic opinion at that point. And the language itself is probably fine. It looks statically typed. That's, like, my biggest, like, Python? Is it, like, statically typed? Because then as soon as I see Python, I'm like, probably not statically typed. Probably enjoy Python for the wrong reasons. Most people that enjoy Python, See, the thing is, it's very good for learning very initial programming concepts. But types, a lot of people find types to be hard. Once you learn types, they make it easier because you don't have to think about types anymore. A lot of people like, oh, you have to consider so many things when you write Rust. No, you don't have to consider so many things when you write Rust. The compiler has to consider many things, and you just have to tell the compiler how to consider those things. You can turn your brain off when you write Rust because you know that you don't actually have to. You don't have to be the one making sure your code is good. The compiler is. So as soon as I write code, I don't have to remember how to use my code correctly anymore because the interface is in the code itself. And it enforces that I do it correctly. But no, I've seen the work that goes into a PhD. I have not put PhD level effort into learning Rust. In a different life, I would pursue a PhD, though. It's because looks like several of my parents' generation, like my dad and like some of his siblings, they have like PhDs. And then, like, my sister's also considering getting a PhD. And I'm sitting here like, and I dropped out. I have a grandpa who just, like, kept going back to college for fun. Maybe at some point I do go back to school just to get the piece of paper. Define, compare, op for. And we don't do the operator. Generally agree, but I do appreciate the simplicity of Python, and I do think a lot of their language-aligned philosophies are pretty good. I have an interesting opinion on that, like the Python Rubies of the world, of like, on one hand, I think making an ergonomic language is good. It is good for languages to be usable by people. That is objectively good and a noble goal. However, I also hold the extreme opinion that developers' lives should never be made easier if it comes at the cost of runtime performance for the consumer. So if the language is slower, that is a sin, in my opinion. To make the programmer's life easier makes the consumer's experience worse, or like your back-end costs higher or anything. Like, if it requires more compute to make your life easier once it has left your machine, I'm all for your development environment consuming the wattage of a small country. I'm all for that. But as soon as it leaves your computer, it's a compiled binary. Like, it should be fast as possible, as optimized as possible. And I very much prefer putting myself through torture so that the code is faster. And it's very interesting because I listened to a 6-hour-long interview with the guy who made Ruby on Rails. Because he had a lot of interesting opinions, and I think a lot of like good opinions. But there was one opinion he had, which is like, the way he posed Ruby is that it is a luxury language. In that, like, if your company is profitable enough, you can afford to have a luxury language that requires more compute, but it is nicer to write. And I was just like, no, because like, I hate that opinion. It's such like a, it's because to some extent it is true from a business person perspective. Your infrastructure can cost more if you are profitable, and then it is fine. And like, if your programmers are able to ship faster, that is objectively a good business thing. If you're able to write code faster and land clients, the quality of your code from a business perspective really doesn't matter if you're making stuff that people use, because it's valuable. Even if there's crashes, like the value of having something actually shipped outweighs the value of having something that never crashes. From a business perspective, yes, that is all valid. And that's why I say, like, my extreme opinion of, like, never compromising on performance is extreme. That's why I pose it that way. But at the same time, man, I don't like that is an opinion. I don't like the opinion. Even if it is a valid opinion, I don't like it. It's the same kind of MBA opinion that results in testing production. Yeah. And it's like, it can work, and it can actually work really well for your business. But as like a programmer that treats programming as, programming is my art form and I want it to be done correctly, I don't like having successful businesses. See, test-driven development. You want to know my opinion on test-driven development? What are tests? Tests are assuming that your code works, or not assuming. They're enforcing that your code works correctly, and a lot of people use test-driven development as like, I don't need statically typed languages. I have test-driven development. Now, this isn't like, I do like tests, but not for the reasons a lot of people use tests. A lot of people are like, I use a dynamically typed language and then I write tests. Guess what? Guess what types are? Types are compile time checks on your code. So, the logical, most extreme version of test-driven development is a typed language that uses dependent types. Functional programming is the largest extreme of test-driven development, because you also write your tests directly embedded into your code as you write it. Also think that your language choice isn't the main performance factor. You can write pretty fast Python and also terribly slow Rust. This is true. However, once you get into making code for this, your runtime matters. And also, if you care about like the actual power that your computers are consuming, then it is very good if you have less power draw from a more efficient language. Yeah, found test-driven development kind of weird because most bugs were edge cases or things you never saw coming. Exactly. It's like, if I'm going to write a test for this, I might as well just make the code work. What test-driven development is really good is not for ensuring it works, it's good for ensuring it doesn't stop working. So it's kind of like a, like protection against regression is what tests are really good for. So I like writing tests after the thing is working instead of I write the test first and then I do the, I write the test first, and then I write the, whatchamacallit, Brane, I don't know. Define, I compare for a, define binary op for equality equals, then for types, clone. Actually, wait, this is by reference. This doesn't need to be cloned. And then we can do IR binary operator. I compare IR compare type equals template count root. Nice. I guess I do have to clone this just for safety. Then we do equals. Do I have a not equal? Yes, I do. Not equal. Greater equal. Then we also have greater than. And I don't need an identifier on this. And then I'm also going to copy this for fcompare. And then it's exactly the same. Let's see, well, what I mean is your code doesn't become magically optimized because you've picked a language that can be fast. You actually still need to write optimized code. Yeah. And some high-level languages can, in practice, be faster than low-level languages because they might provide optimized, high-level structures that a low-level engineer might not think about. Yeah, but that's not a case of the language being faster, that's a case of there being abstractions that the coder can use. That's just a skill issue on the lower-level language author's part, because that language still could be faster. That's a programmer diff, not a language diff. One of the weird things about AI being pushed to be a programming copilot is the whole vibe coding thing. Consistent predictability is very important for code to have. I guess after you get it working, yes. The concern I have about AI is that it's pushing us towards, like, AI is better at the human readable languages, even though it should really be being pushed to, because it's like volume of training data, right? So JavaScript is what it's best at. when, in my opinion, we should write all AI-generated code in languages with as many static verification checks as possible, because I don't care how good a human is at memory management, or thinks they are at memory management, an AI is definitely bad at it, and will probably almost always still be bad at it. And that's the thing about AI, is it's unpredictable. However, you know what's not unpredictable? Static validation on a compiler. And guess what? Also, AI can't complain about writing Rust, so we should just force it into the Rust mines. My personal opinion is to use the language you enjoy, as long as it's good fit for the task. For lots of reasons, in practice, doesn't matter. Unless you're picking JavaScript, then you're wrong. Based. And I agree. Lack of reliability, based hallucinations being confidently wrong, is antithetical to us being emphasized during comp sci degrees. This is true. Guess who's pushing AI? Not comp sci degrees, business majors. Let's go. Everyone should just use assembly. Also true and based. That's my main point. The language on its own being theoretically faster doesn't mean that in practice, if the programmer isn't, doesn't mean in practice. Blah, blah, blah. I can't read whatever you're saying. I'm not currently literate enough to. Yeah, but that's my main point. The language on its own being theoretically faster doesn't mean it is in practice if the programmer isn't able to fully utilize it. In practicality, yes. However, in most of what I do, I don't like being practical. I like being not held back by the language runtime. Bad code runs slow. True. And think about it like this. If you build a product on a language with the potential to be faster, then all you need to do to optimize that program, if it does need to be optimized. Now, if you're in a situation where code doesn't need to be optimized, like a dev environment, or, I mean, in a lot of cases you do want the dev environment to be optimized, but if it's like a one-time run code gen, or project configuration, Python scripts are fine. If it's a one-off dev tool, like, hey, AI, vibe code a FFmpeg script that does these things, like a Python thing that goes through and does FFmpeg commands or something like that, that's fine. One-off, non-performance related things. But the instant it's like, at some point I might need to refactor this to be fast, then I want that in a format that is refactorable to be fast, because I can run a flame graph on a Rust binary and then go, my code is slowed here, but it's not slow because of the runtime. It's slow because of something I did, and I can change what I did. I can't change runtimes. Well, I can change runtimes, but I have to rewrite my entire tech stack in production at this point. So I'm kind of just like, start with the by default what is scalable. Now, there's a business counter to that, is what if you never scale? If you get to the point where you never scale, it doesn't matter what you wrote it in. If you could, from a business perspective, all of my answers to things change if I'm actually starting a business. If I'm hobby coding, my answers are build it correctly. If I'm business coding, get it working. If I'm working with Meta Horizon worlds, I do not care about any semblance of quality. Okay, I do. I care about user experience, but my actual code quality, I stop caring about. Because, yeah. Okay, and then we need to do... Fine. I compare for... ints define f compare for floats. And technically we should also define this for pointer and boolean. So I'm gonna copy define I equal for this, and we're going to grab this, throw it in here. For types, clone. And then I'm also going to define, actually we only need I equality, integer equality, because then we can define I equal op for bool and pointer. And this needs to actually, pointer equality needs to be a, that needs to be a template. Yeah, and that's my opinions for experienced coders. My opinions for when people are learning, they should learn with whatever works for them. Business people tend to act like you get what you pay for doesn't apply for when they to what they spend to develop their product. See, the thing is, they generally pay their coders a fair amount to write Python with an LLM. So I have my addition. Oh, here's my actual list of binary operators. We already have all of these. So we should probably do unsigned, unsigned remainder. Define binary op for remainder, and this will be remainder signed, unsigned, crazy noob. I still can't get SQL work. I've been coding for over a decade, and I still have to refer to the documentation whenever I'm touching SQL. And I have done a fair amount of SQL. I can never remember all this stuff. SQL is interesting. Or SQL. However you want to do it. Profession where no matter how good you get, you'll always hate the code you wrote last week. This is true until you write Rust, and then you lose your mind. It's not as interesting as regex. That is the one thing that I will say without shame, that I use AI to write every single regex. I do not want to touch regexes. Do not want to touch regular expressions. I don't want to deal with binary operators right now. Or with bit operators. I'm gonna say bitwise operators. Because templates are needed. But I actually feel really good about actually having implemented all the stuff for these. But now we just need bitwise operators, which are an absolute pain to deal with. Like the special expressions, they're just regular expressions. How bad can it be? Yeah. Specifically 20 minutes of your stuff not working. Alright, I think we're ready. No, I should really implement bitwise operators. Okay. I will be right back. All right. I realize we have other intrinsics that we need to implement here too, like indexing, whatnot. It does take a minimum of 4 hours between regex. It is true. Man, I don't know how I'm gonna get slices to work. I really made this benchmark hard on myself, more so than I needed to. Okay, bitwise operators. I'm going to leave them as a to-do for now. And then let's implement slice and index. So, root, insert override, slice, and slice be defined as wait, I have a intrinsic op function. There we go. And for this one, we just need whatchamacallit, type pattern any, because this really can be in any type. And then our actual argument into here, which is the length. The absolute maximum length of an array in Brane script is 32-bit, or yeah, 32 bits. So I'm gonna say native type U32, and then our callback is going to be type args context. Yeah, and then we want to how have I defined slice types? Behind the scenes, slice types are a pointer paired with the length of the thing, so it's a wide pointer type. Hmm. Yeah, this has to be a struct. I don't want to... There we go. You know what I should do? I should create an implementation of this. New slice and have it be pointer, and then have this be a reference to no, we'll have this be our value. Pointer and length. The length is also a R value. And the reason I'm having them be R values instead of directly just values is so that I can type check this. And then this is what fields equals. We don't have a def ID for this struct. Do we need a mutable reference to a module to define this? I think we do. So in here, we literally do this. I'm going to say let our value pointer value, then emitted pointer type. This must be a pointer. Do I need this to be a reference, or can it consume it? Probably fine if it consumes it. Expected native type, found type. Because if this is a value, it's IR native. Ah, okay. There we go. Must construct a slice from pointer value, but value was that. Do I have debug implemented for this? No. I kind of should have display implemented for this. This is honestly kind of a compiler error. This is fine. Must construct slice. Slice length must be U32 type. the length value. Ooh. I know what I need to do. Slice type. Then I'm gonna say inner type. Then we throw this whole deal here into this function. Ooh, wait. This is true. We need to have option. IR type. Because pointer types are optional. Instead, we do inner type map. Like so. Boom, and just like that, I have a consistent definition for the slice type. So then I can go let def ID is equal to self slice type inner type module. Just like that. Ah, that's so cursed. Hopefully the optimizer can deal with that madness. Okay, some pointer to string. Type here. Goes the inner type. Oh, I don't want inner type here. I want this to be of type IR native type pointer. Inner type. Oh, right. We're constructing the actual structure here. Okay, so now I have an easy way to define slices type safely. Alright, thank you for sticking around while you could though. It is appreciated. Okay, and then up here, slice type. inner type. And then the actual module. So that's context readable module. And there we go. Feel a lot better about that. This dealing with, well, it's just straight up not. Because I'm not actually representing tuple types yet. I mean, I can represent tuple types, but I can't represent tuple values yet. Then why did I want slice types? I wanted slice types for the slice intrinsic. We can just do new slice. Of, well, first we have to actually do let data equal context emit operator. Yo, how goes it? Operator, and then this is going to be a unary operator, I think. IR unary op allocate. Wait a second. Ah, right. Just unary operator. Nope. That formatted that really weird. Right, I just need to do operator, then binary, no, unary. Then we can do IR binary op, then alloc, or no, unary op. And our value is length. And then for the actual length, I think I can statically say that this is IR type native, IR native type U32, and just throw that into the match statement. What is the goal of this stream? So the goal of the stream is to run this code over here, which is the kind of basic 1 billion nested loop iterations benchmark. So that's the, you know, the one that looks nice with like all the balls bouncing back and forth of like all the, yeah, 1 billion nested loop iterations benchmark. And everybody, there's a certain brand of coder that whenever I bring up that I want to like do this benchmark, that brings up all the reasons why this isn't a real benchmark. Yes, I know. I'm doing it because it's fun, not because it actually says anything valuable. Aside from the fact that my language is going to be about the same speed as, hopefully, somewhere between Java and C or Rust. Somewhere in here is going to be my language. If it's as slow as JavaScript, we're cooked. If it's as slow as Luigit, we're also cooked, because half the point of making this entire language is like, oh, I can write something faster than Luigit. It's interesting we don't have any Wasm on here. It'd be really nice to have Wasm on here, because I would basically want to match the performance of Wasm or exceed it. So like a Wasm time Wasm, I guess if we had C plus Wasm in here, that would be really nice. Yeah. Yeah, this is my implementation of the code used to generate the time info that is required to do that benchmark. So right now I'm just working on adding the language features required to actually do that, because it's a fairly good test of the language, because I have to interact with memory, I have to interact with loops, I have to interact with like a fair amount of different operators. You have to dereference. Oh, well, actually, reference and dereference pointers. So I actually have to implement memory and pointer support, as well as slice array support, which is what this index intrinsic function is for. And yeah. I guess I have to have these be templated as well. I feel like very quickly here I'm going to have template argument inference set up. Expected native type found. Ah. Well, that's easy. So this returns a value. So after we allocate this value, ooh, wait a second. I need to catch myself because I need to allocate a vector of the size of we need to emit one binary operator that is IR op or binary integer multiplication, and then our left argument is going to be length, and our right argument is going to be IR value const u32. So we're going to multiply this by let's stride equal to context. Well, actually, we need to do type. This is that. Ooh, have I not implemented? I have not yet implemented layout on this type, even though every single one of its subtypes implement that. So we're going to implement, actually, did I put layout on module? So we have size alignment on module for type. And I think that's good enough. You're going to say context, mod context module, size align for type. Here we put in length, and then so this will properly allocate the correct size of buffer for this stride. If I actually implemented the allocate, that is. Which I haven't yet, but it will eventually. And then here we set data to bytes. So construct a new slice with data and length. Expected R value, found value. Right, this needs to be R value of type data, and then the actual value stored here is going to be IR native type pointer, and then this is going to be a pointer to option sum, and then the actual type there we go. I believe this is valid. So this will construct a slice using template arguments, which is very nice. Do I have to implement typecasting? I'm kind of feeling like I have to implement typecasting. Eventually these will probably be templated, maybe. I'm not sure. And then this one, I don't even know if we can use intrinsic op on this one. Yeah, so basically this needs it as an unsigned 32-bit integer for the actual in-text, and then and here we need not an exact, actually. We need, well, kind of. A struct. But then again, I can't specify arguments with this type pattern system. I can't use templates there, so I kind of have to do, unless I want to fully implement how templates work, I need this to be just type pattern. Any works here, because I can't really do more advanced type patterns than that. I may have just gotten running lights for my car. I heard somebody drop a car, not a car. I heard somebody drop a car outside my door. No, I heard somebody drop a package outside my door. So I think I just got the running lights for my car. Yep. Yep. Can you geoguesser that? Make sure. It's like I want to show it that I'm like, wait a second, let me not dox myself. Scroll down a little bit. Okay, so we have the ability to make slices. We need the ability to index slices. For now, we're gonna ignore just gonna straight up ignore the template arguments. We shouldn't. I guess we're fine to ignore them. I would like to assert, but we're fine to ignore them. Then we have arguments. And we need 2 arguments. We need index. And then we need this to be our value struct. And then we can even go further and fully destructure the can you pattern match on a vector? Not really. No. And I'm gonna say this will be pointer length is equal to fields as slice. Then we can turn this into slice destructure instead. We're gonna do this, but it's going to be bail instead of unreachable. Because this is not unreachable, because I'm not able to specify in the pattern that this needs to be a structure of a certain type of structure. There's a reference to string box arv. Ah, it's boxed. Okay. It's the door on the way out.
Yes.
All right. Yep. Oh, I thought that was a package. I mean, I do have a package. Possibly sitting outside the door right now. So I want to deconstruct this. can do, if I turn this into a reference, then we can do our value wait a second, string. I can't match on string, I can only match on slices, I believe. What if I did a as slice helper function here, which just returned a tuple of IR value? Just like that. Hurts this as a struct. Checks if this struct represents a slice, and if so, returns inner type Actually, I'm gonna keep it as a keep this as R value. Okay, so the first step is incorrect field count for slice. I'm actually going to do, I am going to do a match here. I'm going to say let then we're going to say if pointer We're going to say if pointer label is not equal to pointer, fail, or and then finally, we're gonna make sure that for pointer layer native type pointer, and I don't actually need to know anything about this pointer other than that it is a pointer. And then over here we also need just to check that our value is a value, and that, or that length is our value, and that IR native type U32. Ooh. Expected struct box or value. Okay, it's box. So now, if all of those checks pass, then this is in fact the correct structure for a slice, meaning that we can return OK. Cool, and now we can go back to here. And say let pointer length equals SSA struct as. Oh, wait. So then we have our pointer and length values that we know are correct. So we can then say pointer type. I'm going to do r value pointer type, like that. Higher native type pointer. Inner type. Our value length, and then we don't care about the length type. We have the inner type as reference. So then we actually have our stride of how many bytes to add to this index operation. So on our left, not the length. We want to index this by index here. And then we want to multiply this by the stride. And then allocate that. No, that correct. No, wait. This is the index. This one is correct. This one. That's our pointer. And I think, if I'm not wrong, we just return this as a pointer. This is going to be an R value of type value with pointer as our value and ir native type pointer through And then inner type. Wait a second, this is our offset, and then for our actual pointer, I add here, 1 second. I need to do some quick math. 10,000 times 4, and I think I already know the answer. 40k. This is bigger than 16k. So this will actually be a good test of if my theory of values rolling over actually works. Because technically, with the way I have my memory bindings set up for the test already, this will result in an out-of-bounds memory access. But because of how I've written my code, this shouldn't result in an out-of-bounds memory access for the host runtime. But it would cause some wonky stuff. For the actual, like, script as it runs. Yeah, so we add on the left pointer, and on the right we add the index. No, the offset that is calculated for the index, and then this is our new pointer. Then maybe we want to add like range check here that traps. I don't know. That should be an actual implementation of index. Index is now theoretically implemented. I just realized we don't want this to be a remainder. We want this to be modulus. Actually, remainder and modulus work different with negative numbers. We'll keep this as remainder, and then over here we'll just have that be remainder instead. So the very last thing we need on our runtime side before we're actually able to run this code is run this code and get a real result is, I believe, casting. Casting or the ability to define what my constants are. And I don't even have intermediate code representations of casting yet. So I don't really want to have to deal with it. The way ints handle this is, well, actually, I guess you can have like signed extend. For upgrading and downgrading integer types, and then you need the ability to convert from floats to integer. Yeah. So I need both. I need both to increase my grammar. My siblings are being really loud right now. What if that's showing up? The other thing I need to implement is the dereference syntax. So, adding casting is a rabbit hole because we need to actually implement that into our intermediate representation, as opposed to... my iris is like doing something weird. There we go, we're good, we're back. As opposed to just changing the syntax of our grammar so that we can actually specify what type our constants are. Specifying what type our constants are is relatively a lot simpler. So I think I'm going to do that instead. And For number, it's going to be... Actually, let's not do number or string literal. Let's do... Actually, this is Rust. I can just say int. Or rather, this one's... This one will be float. Let's just straight copy it. Labeled integer or float, and the way int, we don't do digits or not. This could be number. They can both be number. By default, this one is integer. This one's going to be literal is a choice between float first, because it has the more complicated syntax, int, and then string literal. Actually, no, we don't want to unwrap that. Here. I want to just copy all of this. It's kind of what I need to do. This will be our prefix, or postfix. Suffix? I think it's suffix. This will be number suffix, which is a choice between I really should do this. The grammar, not on the grammar side of things. Create a this will take a hot minute. That's fine. Lets me think a little bit. I'm just lazy and didn't want to have to write the boilerplate for having entirely custom literals for every single type. Even the Rust source, they just store number literals as raw bits because they don't want to have to manually fill out this entire thing. We'll keep the grouping. So from the level of grammar itself, int okay, yeah, I have a plan. So we have these base 10 digits. Get those as a slice, and then we try to map them. Now, what we also want is then choice or not. And all of the choices are just U8, U16, U32, U64. I could get the intern to do this, but I'm committed now. There we go. That is all of our possible choices. Then we kind. So literal, since this is trying, this needs to be okay. Literal. Then the literal kind is based on match. And I think I'm going to do U64. I64 as the default constant size. So wait a second, that's why it wasn't working. This needs to be S and then digits and then suffix. And this is going to be string option string. And then I'm gonna say unwrap or I64. Then if this is U8, and we want to do literal kind, or rather, no, we'll do U. Digits parse U8 map I816. Did you just straight up forget? Maybe I accidentally deleted it. I'm gonna give it the benefit of the doubt and say I accidentally deleted that. Expected AST, literal kind, found result. And so we're gonna say map error rich custom span E. Give me error. Okay, no error. Yippee! Can the type checker figure this out? I think it can. When's the BraneScript 2 releasing? Bro, we're on BraneScript 4. Then we just need to do F32. And then we have successfully copped out of... Well, actually, I need to finish the rest of this. Oh no, there's so many errors. Why does parsing int and float have different error types? Why? Now I have to go and paste this on the end of every single one of these. Because no, it can't be a parse the thing error. It has to be a... Because look, this looks so much worse. Such a massive block of... Okay. Now, I'm just gonna copy this. And then we're going to nuke it to only work with loading point values. Yes. Then ignore. Just a period. Then digits to slice. And then we're gonna have a 32-bit float as our default. You should be able to tell that the span gets consumed in control flow where we exit, but okay. This shouldn't need type annotations. Boom, it is a span. Man is type checking, chugging right now. Okay, and now back to integer, or float, where our only suffix types are F32 or F64. Then what else do we need here? We need characters. I think that's the only other thing we need is character literals. Need. Hmm. Yeah, all of that is returning literals. Give it a second. Now it's all the same type. Don't know why I did it that messily, but it's fine. While I was creating string literal, I think I'm going to copy this to escaped char. And what this will return, what does this escape sequence return? Straight up char. Amazing. This will return char. And then for char, Can do escapable char. Added by just of course we need to tokenize this. Then the literal kind for this is char. So this takes a hot minute to compile, but hey, it works. Oh no. Audio gone? Okay, we're good. I think... Let me do some quick, type erasure to... like help out the compiler. I think escapable char is probably one of the big offenders, so I'm gonna say Chomsky boxed. Performance. Improving compilation times. Rust can struggle to compile code containing very long types. And currently, the type of this parser contains the entirety of the parser. So all of the code you see here is shoved into the type definition of the parser. So I'm going to break that up a little bit with the parser boxed. Because it was when I added strings that it started getting like really slow. Okay, that should significantly increase our compilation times just by popping a few of those in there. And also, with that done, we should have all the grammar concepts and runtime concepts needed for this to actually run. Theoretically, kind of, sort of, maybe, possibly. The one last thing we need to do, aside from implementing remainder, maybe, is actually get this dereference syntax working, because currently it's not implemented. If we go to Brane C source, no. You just go to Brane C. Right, this needs a expression count or template count. And now, okay, there's one last thing we need to do, which is implement function overrides. Before we can actually use all of that type syntax to do things. Okay. You're gonna have the intern do this. Okay, so what's left to do? What's left to do? This dereference syntax, both R value and L value versions of it, which are placer value if you're doing the Rust terms for L values and R values. Then we have to do function operator overloading, which function operator overloading is going to be a little bit of a hassle. Unless I kind of botch it, which I might kind of botch it just to get something working, because it is nearly... I want to have this working by 5. Having this working by 5 would be nice. Methinks this is taking a long time. Wait, this is because it's on... This is because it's on thinking mode, isn't it? Yeah, it's on reasoning mode right now. Is there a way? There's not a toggle to turn on reasoning. Or maybe it's thinking? Nope. I mean, something's happening. I might just nuke this. I'll give it 10 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Now watch this. So that was supposed to switch to OpenAI instead of Olama. Dang. Okay, I'm gonna try one more time to get out of coding that myself, because I really don't want to. Oh my, I didn't save my workspace layout. That's fine. Come on. Is nothing working right now? There it is. API rate limit reached. So it's actually trying to do something. Don't know why my rate limit's reached. I didn't really use it for much. But I guess we'll just have to do it manually. Is fine. I don't want to have to tediously go through every single one of these. Okay. There is no U128. That is fine. Or 128. So I'm gonna go to parser. No 128. No 128. For some reason I thought there was. Okay, U8, I8, U16, I16, I32, U32, F32, U64, I64, F64. A little bit of trivia while we have some downtime. I learned recently that the reason that we use I as an indexing variable isn't because it's short for index, it's actually because I believe Fortran, early in its development, would just treat every single variable that starts with an I as an integer, and then every other type as not an integer. So every single loop index would start with I, or it could just be like the single letter I to denote it as an integer. And we just kind of stuck with that, even though even Fortran itself like soon after that got actual type support. So you were no longer saying, you no longer had to name everything F, like index it with an F. Or I, sorry, I was working with floats. So I was thinking F, but no. Index with I meant I. Yeah. Okay, I do have a constant bool. Do I have a constant char? Actually, I don't have a constant char because chars are unsigned 32-bit. Let's see, VUTF, and I do as U32. What does escape Unicode do? Returns an iterator that yields the hexadecimal Unicode escape of... Interesting. I thought it came from regular math syntax, where IJ are common names for iterations. It might be. Also, how close to the benchmark? We need to add one syntax feature and then finding functions, basically. Rewrite the current way that we find identifiers to Instead, find them using the actual namespace system. So I'd say roughly an hour at most, maybe 2 hours. 2 hours at most is a very safe bet. Possibly sooner. Note that all chars are valid U32, then it can be cast as U32. Well, then I can be do that. Oh, apparently, yeah. I got juked before. Okay, constant's done. Next thing we move on to is the dereferencing syntax. I'm gonna ignore this for now. Basically, we need to do emit R value, path deref here. Since this is an R value, we want to get the value contained by a pointer, meaning that this should... we should do a self load on this expression. Let pointer equal emit R value expression. And then this should be a pointer type. Okay, and then we need to convert this into an L value. So if let R value pointer, and then also not box. Our native type pointer. Inner type is equal to pointer. Actually, I'm going to do regular guard syntax on this. Cannot dereference non-pointer value. Pattern has one field, but the corresponding tuple struct has two fields. Ah, right. Did option R value? Okay. Oh, wait. Expected option R value, but found enum R value. Oh. Is this screaming coming through? There are children screaming. Many young siblings. So then we want the pointer to equal to be a left value instead of our R value. And we can upgrade this because it is a pointer. Runtime memory address and inner type. So this will be pointer and inner type dereferenced. Say let some inner type equals inner type fail cannot dereference void pointer with unknown. I'll actually give advice in that error, which is not on brand for the moment. Okay, so in the case of dereferencing this as an L value instead of a R value, we just need to not load the pointer and directly return it. So in the case of L value, deref, we just do this and return a pointer. Just like that. And that finishes our reference and dereference syntax. Or not... Well, not our reference syntax. Not our reference creation syntax, but our, like, dereference pointer syntax. That was something I have not been able to figure out for like 4 years, and it was that easy. Now, next thing we need to do is when I return a callable, do I need to figure out the function arguments on that? Yeah, so that's taken care of. Last thing we need to do is in emit callable, we need to... Somebody dying? Okay, no, they're not dying. They're fine. Come on, Brane, don't crap out on me now. This is literally the last thing we need to do. Alright, so what we need is not a template definition. Well, yeah, get a template definition. Somewhere in here, path, get variable at path, not get variable at path, I need resolve def, here it is. And after resolving a def, what is a resolved definition? Well, we have two options. We have resolve function, and we have resolve function or resolve type, but both of them use one of the same interfaces, and that interface is resolve which template to grab from, because we're just going everything's templates, easy. And here we're going to return not an option, because if we fail to resolve the path, it's an error. Let's say resolve path. We'll stick with resolve template. And this will be results. Work with me here, Brane. And I don't want this to actually lock the module context. Because this has the ability to lock the module context, and I don't want that, because we want to be able to do other stuff with the resolved template. So instead, I'm going to do... I might have to clone the AST of the function. Actually, in most cases... hopefully not. There's lots of fancy things I might need to do to instantiate templates correctly, but as it stands, namespace, and then we're going to resolve this within a ident. Ident scope. And this is cleanly recursive. We can cleanly recurse this. We're going to use a slice of path segments instead of an actual path. That way I can rescope the actual paths. And first we're going to check if the namespace let some sub namespace equals namespace subscopes, get say let some segment equal path first, else fail. Let's throw an assertion in there. If path length is equal to, or is less than 2, I'll say. Fail. Expected definition, not namespace. Otherwise, we're going to just do self resolve template path and then 1 path length. And that handles deeply nested scope namespaces. Not that we need that. Path segment doesn't implement display. We need to fix that. Implement display for path segment. Is display implemented for template arg? No, but maybe type. We do need to implement display for type. You want just... Yeah, no derived macro for display. Oh, it will. It will implement that. I do not want to do that manually. Work with me here, Brane. Right. Wait, is it because they nuked everything? Why is this all Copilot? Okay. Let's see. Implement debug, not debug. For every type in ASTRS. Man, I've been streaming so long that YouTube, are you still watching us? API request failed with status 429. Rate limit reached. Okay. Oh, well, thank you for sticking around while I kind of bumble around. I'm trying to see if there's something I can do to unrate limit my account so that I can actually just say, hey, implement display for everything in this file. Because, like, I don't need... Okay, there's other solutions. Like, I could just bring up a chat window, but I want to... I would like to be able to, like, in editor, vibe code stuff. Like, I really like using it for display traits because, like, it's mostly boilerplate. Can I find out? I have spent 50 cents on this total. And apparently today, I spent 4 cents. I didn't do anything. It just said rate limited. One single request, and then I got rate limited. Can I be told what request that... which model that request was to? The maximum usage OpenAI allows for your organization each month is $100,000. I spent 50 cents and I'm getting rate limited. Okay. That's 500 requests per month. That's fine. I don't think I'm reaching that. Or requests per minute? Is that it? It's like... Yeah, look at this. It's like... What? I guess that's not very visible. Anyways, take my word for it. It says TPM, so that's either 3,000 tokens per month, and I absolutely nuked that. Yeah, no, wait, there's the explanation for it. Tokens per minute, and requests per minute or day. So I should have more than enough tokens for ChatGPT 5. Like, I'm not going through 3,000 tokens that fast. GPT 4.1 is also the same amount. And that's tokens per minute. I go to usage. I've done 1 request today. And the input was 14k tokens. The output was 2k tokens. It's like 16k tokens total. And this was to GPT-5, apparently. And then immediately got rate limited on GPT-5 dash 2025-8-07. Which, if I look at billing, oh no, not billing, limits. That version of ChatGPT 5, I have a 30,000 tokens per minute limit, which I guess I'm nuking. And then this is 9,000 tokens per day. No, or 900,000 tokens per day. I don't know why this is getting rate limited. Do you have an ETA for the scripting language? Currently, roughly 2 months at absolute worst. At absolute worst, 2 minutes. Not 2 minutes. 2 months. And then let's switch this to... Why don't we just say switch to GPT-5? Trying in 10 seconds. Because theoretically I have enough tokens for GPT-5. I have the same as O4, and I was using O4 a ton. Considering the rate at which I've been working at. Yeah, if I can keep up the same exact rate I've been working at, maybe not this week, but the week before that. Actually, no, it was this week that I got a ton of stuff done, wasn't it? No, it was the week before that I got a ton of stuff done. Then it would be like a month. But hey, look, we're actually getting completions. Let's go. It's really slow, though. But hey, it's supposed to be better. Will it go over 30,000 tokens per minute? Probably. Don't go and do another revision. This one is working so far. There's no reason to revise this one at the moment. Yet. Why is it slow? How much data is it sending to OpenAI servers right now? I mean, I'm streaming right now, so we're sending a ton of data, but we're receiving like nothing. Maybe that's to be expected. Come on, you're supposed to be fast using the actual API. Nope. Something changed. Out of the corner of my eye, I saw something on the UI change. Come on, this isn't... We're not building a rocket ship. We're implementing display traits. I probably won't restart at this point. Probably. you allow yourself to restart, don't you think you might do it for way too long? Oh, I know. I've been working on this project for 5 years. Though, that's why I'm like setting actual goals for myself. I did the restarts because I thought I wasn't going to do it fast enough this time. My scope was too large on the past versions of it, and that's why I restart, to actually lower the scope and do something simpler. So, the restarts did not slow me down, they have been speeding me up. I might restart this prompt, though. Oh, there we go. What? No! Print just the identifier for a single path segment. Template args, if any, are intentionally omitted here to match how the path currently format itself. No! That is not what I want. Why is it stopping? Oh. Do I have to wait for that entire generation to finish? I guess I do. Okay, we're switching to 4.0. And we are retrying. Yeah, I know. It will actually be done fairly quickly soon. Okay, looks like it doesn't want to do 4.0. We'll just try GPT-4 then. I could have probably implemented all of them by now. Then let's actually do GPT-5 mini, if we can. Wait. Copilot. It was saying I was rate limited because it was Copilot slash GPT-4o, not OpenAI whatever. So if I go OpenAI GPT a 4.0 mini like that, well, I saw a flash of tool calling, so I think this is working. See, this was like super fast like a couple days ago, and I got addicted to it, and now it won't let me use it. Okay, where? Where? Well, I guess I'll just say yeah. Okay, yeah, this is slow. I'm just gonna do it myself. Ident, we have template arg, we have do I have okay, I do have quencoder 14b. So let's just switch to that. Eh, Okay, so I now have switched to an incredibly fast model. So this, I should be able to implement display traits really fast now. Holy crap, I should have switched to the 16B model so long ago. Wow. That is all I need. Cool. Now, where is path? And this is a local model running right now. Oh, it even took into account mutability pointers. Let's go. Very nice. Huh. Okay, so 5.0 might have done this, but I didn't catch it. Or 5 might have done that. It was at the end of the file in the keybind to jump to stuff. Didn't happen. Didn't work. But yeah, that's implementations for the rest of everything. They're actually good. It did generate stuff. I just didn't see it because it didn't put it in the correct locations that I was expecting. Which means now we can go back to where we were after this giant detour. Path not found. Path. Yay, our debug messages. We can now say failed resolve path segment, and it correctly does it. Alright, and then we say if let some temp is equal to namespace defs get segment ident text Okay, so actually, if we actually get a template, we return, okay, template. And tie those two lifetimes together, and we're good to go. Okay, and then we do self resolve template. No, wait. Self resolve template. We don't need context. Then return path segments. Then we return namespace, or use namespace. Construct enum function pipeline. If I do type instances, if let some equal context type instances get TID Okay, so that memoizes structure creation. Even though it's already memoized. This is just in case we do templated functions, memoizations. Context is already borrowed by context namespaces. See, it's using two different types of the module context, but I can't necessarily split the two. But I want to keep the reference to template. And I know all the template resolutions aren't going to change, so it's fine. This is instances where actually, since the namespace changes constantly, or can change constantly, I'm going to say it's not part of the module context, and it gets passed into every single other function by itself. And then when we emit function, we need to pass in the namespace. This also allows us to evaluate other stuff outside of our module, in differing scopes of our module without having to edit the global state of anything other than just the namespace. Ident scope. To emit function within this identifier scope. And explicitly, well, I guess I do have it as mutable. But while we're emitting a function, we don't want the namespace to be mutable. We want it to be immutable while that's happening. And now this gets put into every single function. Maybe I should return the namespace that I find definitions into. That way if I need to emit further types, like nested types, I can emit them within... Actually, that doesn't make sense. Now here, do a namespace. There we go. If you ever run into problems in Rust, the solution is to individually pass every single thing into a function instead of using structures. Because Rust has no concept of what values of structures are being used by functions. Which is something that I kind of would want to add to a Rust 2.0 language, is the way to know as a way to semantically check what gets borrowed by this function and what references to what things are retained by what return values. Oh, okay. It did not crash. Which model is that? Which one are you referring to? The one that was going pretty quickly? The one that was going pretty quickly was Quen Coder 14B 2.5. Sorry, I didn't have Twitch chat open there for a while. I had my OpenAI limits open up. Okay. No errors in this file. Now, which is suspicious. I'm gonna fix this. Passes. Fix the map values function. To match the new format of the enum. Let's see how well a 16 billion parameter model does at tool calls. Super interested in this. Okay, we're going straight to a replace in file. Oh, failed. E. It got me close enough. No. We just have the backend complaining. But we should have emit callable. Emit callable should use this. You know what? We're gonna keep trying to vibe code here. So we have librs, and what I wanted to do is then we also need to give it What do you want to give it for reference? I don't know. I think how much of this is... All of it isn't defined in this file. So yeah, it works. Implement emit callable by using resolve template to retrieve a list, the list of overrides for a function handle errors if it bail if the function is not, or path does not lead to a function. Then select the first override that matches, or select the first override that both the template arg types and template arguments. This means that emit callable needs to take into account the arguments this needs to take into account reference of IR type matches both template arguments on the last path segment and function arg types. I just want to see how well it does, because that's like a fairly difficult task. It's doing better at the thoughts thing than it did last time. And it failed at the replace and file, but it needed to fail last time to actually work. It is not doing too hot at replace and file. It's really struggling. Request how do I get rate limited on my own computer? Okay, we write this ourselves. Enough playing around. Okay. Self-resolve template using path segments. Not some, we do template function. Okay, so for every override, no override of for arg types Okay, so for every override, we need to check if every single element in this matches the possible arguments to the function. What is BraneScript? BraneScript is the scripting language I am working on for my VR-focused, user-generated content-focused game engine. So, yeah. that was not the smoothest way I've explained that in the past. Basically, I'm trying to create the fastest scripting language ever because I'm trying to run it on a quest and also runtime load scripts from like servers and stuff, so it needs to be sandboxed and secure and stuff. Yee. Why I didn't use Python? Because Python is slow. Okay, so... You know what? I am going to... function override. We're going to implement a function for this. We're just going to say going to say valid for, and then take in, we need both template arguments. The valid for template arguments, and this is going to just be a slice of IR type, and also a slice of function args. Oh, and of course, reference self. So first off the bat, if temp args length not equal to and eventually we'll have like template inference here. So like from the function arguments, you'd be able to infer template arguments. But for that, we need a little bit more patching. We would need a little bit more pattern matching than I'm willing to write right now. So, well, just a slight bit of pattern matching. We'd need to be able to do full pattern matching, basically. Yeah. Public function that is valid for so we just say if function args length is not equal to self arg types length, Then true is going to be our default exit. For now, we're just going to have any and exact for pattern type equals or in self template args iterator zip with template arguments if or actually match on pattern on any, don't do anything on exact if tie not equal to, oh wait. Pattern type if pat type not equal to type, then we just need to return false. Then we need to do the exact same if statement for template args or function args or archetypes. And this should be more than good enough for now. We're gonna say if O valid for we're gonna say let template args is equal to path I'm gonna risk an unwrap here. This should be fine. It's gonna get triggered, but yeah. Template args. Map. Iterator, map. Collect. Map type, self emit type, type namespace context. There we go, we can unwrap it like that. if this is valid for this, return match on O, override kind. This is an AST. We're going to just say to do. And if this is an intrinsic, we're going to do callback and return callable or okay. Callable intrinsic function template args, and then finally callback clone. Okay, that's not complaining. Now when we emit callable, we need to pass in the argument types. Then we need to add namespace to emit R value, and also to emit L value, I would assume. Yep. Okay. Yeah, we might have a functioning compiler now. Compiler front end, that is. I need to rewrite the actual JIT compiler, specifically just this one match statement, and then we'll be ready to start testing. So you need unary, operation, and then value, and then man, this is this is so much cleaner. I'm going to be so much cleaner. We want to keep load around and store around, but all the rest of these I add goes right here. Let's get the left and right from one of these. Add races to the match arm. Boom. Match arms have incompatible types. So this should return option value. I sub. We want this to be SRM, like that. Apparently something's off with my grammar, so it's cooked. Because I cooked this. Then we need greater equal to be that. Then we need a match on compare type. Actually, we can just put the match statement right in here. Signed greater than or equal. Wait a second. This does care about signed versus unsigned. Okay, let's see. Don't need to care about compares anymore. Nice. This is a significantly cleaner way to format that. I mean, you have a little bit more nesting, but all in all, it's less lines of code. This also means in intrinsics, it theoretically works right now, but I'm delaying slightly to say this is define as compare, and this will be unsigned compare. Which, yes, it only uses half the equations, but it's fine. Used result. Where's I equal for bool? Signed compare for signed And unsigned compare for unsigned. Just to make sure I cover all my bases. There we go. Comparisons are like properly implemented now. Technically we're using the wrong IR for unsigned equality, but it's literally the same intermediate code result. Anyways. My NeoVim muscle memory is too strong, so occasionally I'll just press escape when I'm done typing text. And in a lot of programs, pressing escape erases your current input. So, yeah. What did I name this? Loop bscript. Okay. Yo, you got back right as I'm trying it for the first time. So, we'll see what happens. It should at least compile. I'm expecting at least some errors at first. Because, like, there's no way you code for 8 hours is what we're currently at, 8 hours and 21 minutes. There's no way you get it to work on the first try after 8 minutes. Or 8 hours, yeah. We get a Stack Overflow of all things. So let's run this in the debugger so we actually get where in the code we get the Stack Overflow. Oh. Do I not? Following required arguments were not provided. Ah. Okay. You know what? I don't want to have to do these, so we're gonna say option. And I changed the function signature, so these should be 32-bit. I'm glad I realized that, because I could have been stuck on that for a while of like, oh, why is this acting so weird? Except that it wouldn't act weird. Though at the moment we don't return anything, so... Actually, we do return something. It's all good. Unwrap or... I'm gonna say 30. $42. I have no clue what these values do in the actual binary, it seems like they're mostly there to stop it from getting optimized. There we go. There's our Stack Overflow. Stack Overflow from parser? So it's my parser itself that has the Stack Overflow. That's super weird. Maybe if instead of unreachable, we do a panic, it'd be more fitting. Even though unreachables should act exactly the same as panics. Like, it's the parser that's causing a Stack Overflow, and nothing else. This is the last thing that I was expecting to cause a problem. Absolute last thing. I guess process of elimination. Is it the floating point parser? This is the only thing I really changed was the literal parser. So we'll just ignore float. I could also just unbox everything. Like maybe it was boxing stuff that caused it to explode. Oh. We're gonna keep running it through debugger to see. Overflowed its stack. Okay, so by process of elimination, it's not the float. Let's check if it's int or float. Might be escapable character. Okay, no. So it's not any of my constant parsers. Or literal parsers, I should say. Which means it's one of these ones. I have the feeling it might be the escapable character. Okay. So it's not escapable character. There's no way it's... There's no way it's the token literals, the Boolean literals. Absolutely no way. So it has to be string or escapable character. Is like, it must be. And I don't need them to run this test, so we'll just keep them removed for now. Still overflowed its stack. Is it while parsing or... It's while parsing. While it is parsing, it has a stack overflow. I wish it told me what part of the parser had the stack overflow. That would be super useful information. Okay, it is when we create the parser, not when we're using the parser. I'm gonna try unboxing stuff. Which theoretically increases our compilation time, but I would prefer compiling something that functions to compiling something that stack overflows. Okay, it's still overflowed the stack. We're going to print debugging, or we can breakpoint debug this. This is what I should have done at the start. We overflow the stack. When we call the function itself. Or doing anything else. What? Here, one second. Let me try... I mean... having those stack allocated before didn't cause issues, but it's like... that's 16 kilobytes of space. 16 times 8 kilobytes of space. No way. No way that was the issue. That was the issue. Okay. So, the issue was that I was stack allocating this page here, which is quite large, and then trying to call that function overflowed the stack because these two pages were too large. So when the main function was called, when a function's called, it moves the stack pointer preemptively to contain all the data that function will ever need to allocate. So when the main function is first called, it allocates these on the stack. And then when we call parser to try to create our parser, it allocates stuff on the stack for that. And before, when I was doing this with the node graph, most of my program in that instance was allocated. It was using UI to generate the actual graph. So all of that was like heap allocated. I didn't actually have a stack allocated parser. Okay. So I'm doing this just to be safe. See, this is slice as moot pointer, right? I think it is. And then here, when we actually call the function, wherever it is, yes, bindings page. As pointer. And we overflowed the stack. Are slices always heap allocated? Or, sorry, stack allocated. They might always be stack allocated. Meaning that I don't want to do box here. I want to do vector. So we're gonna do vector reserve exact or vector and this needs to be a vector U32 test allocation page resize with value U32 I guess since... Yeah, since it's a mutable vector, they would actually need to stack allocate that. Then down here, wherever, here it is. Want this as mutable, well, actually just as pointer. Because the bindings aren't actually mutated. Alright, we're in business. We are able to compile again. That's so weird, because I've done that before. And it did not cause those problems. So now we fumble with, loop bscript a little bit. Oh, wait a second, this is running the wrong script. Yeah. Or was running the wrong script. Was expecting white space, slide comment. Okay, I don't have an identifier for slice types, apparently. So, to the parser we go. Northern type. Delimited by square bracket token, square bracket token. This is the grammar that we should be hitting. Token mutable or not. It should be all of this delimited by this. Mootable or not? You know what? Let's throw moot in there. Expecting white space, line comment, block comment. Identifier equals yeah, those are all so basically padding, native type, which is I8 through all of those things, including Boolean chart, string, and then or it's expecting an identifier or quality. It shouldn't be expecting an equals. At least I don't think. Expected AST type, found tuple, type expression, type then expression. Then ignore. There we go. So weird bit of parser logic there. Maybe that helps. After kind of straightening that out a little bit. It like functionally should be exactly the same. But maybe now it can realize that, hey, we implemented grammar for slice types. gonna put all the simple ones at the bottom here. That way our fancier ones have a chance to be expressed. Combinator making no progress. Cursor combinator making no progress. It's not good. This is mutable or not? So if I comment out everything except for native type, wait a second. Def separate. Okay, that's a structure constructor. I'm just gonna remove the mutable or not. Because I'm not actually using it at the moment. Because the or nots are dangerous. Well, it got inside of it, so it's making a white space line comment. Oh, it was parsing it as a path. Making no progress, so it's back to that. Is it the slice that's causing that? Wait a second. Wait a second. No. Then ignore equals. So expression, then ignore, then expression, then ignore. That statement. While statement. I wish I could get the state of how far the parser actually gets before giving up. It's so close. Selecting white space, line comment, block comment, or closing bracket. If I do this, same thing. And I know my comments work because they've worked in the past. Just to be safe. Something super weird is up. Just got rid of string literals, which shouldn't really be anything. In fact, I know it's not anything, because the problem wasn't them. I'm gonna add them back. Maybe adding them back fixes it. Collect combinator, making no progress. At librs, right, it gives me the line number of the problem. I forgot about this. Okay, 380. It's template arbs. Okay, I was thinking maybe it was that. Of course, I didn't show any indication of that. I had a brief moment where I was like, maybe it's the templates. And that's why I was trying to comment it out. So it's type that failed. Wait. No, that's properly boxed. That's also properly boxed. Collect combinator, making no progress. 380.18. Maybe I went to the wrong line number. 308. Template arg connect. Wait a second. This was supposed to be separated by token, comma. Oh, it parses it correctly now. Okay, was expecting white space, logging, comment, block comment, or that. So this does expect a semicolon. The problem is with the while. So it's properly parsing this. Then we get to this here. Link type is not currently supported. Dang it. It'd be cool if I could just click on it and it would take me to it. But I'm confused because I remembered the thing. There we go. Expecting semicolon. Was expecting nothing. What if I do an if statement instead? It parses an if statement just fine. That's interesting. Token while, ignore then expression, then statement, clone, delimited by. Okay, I need a better error for that. So while statement should do block statement. And I need to really look into the Chomsky recovery. Oh. So now we're complaining about this. Was expecting white space, line comment, block comment, expression, blah, blah, blah. So expression, one of the things of expression should be expression, define, and it's a call, which is from field, which is from atom. An atom has literal array. Yeah, one of the options here. Was expecting a white space, line comment, block comment, expression, closing parenthesis, equals let if while match. Basically all the different expression things that it could be. Assignment. I say, so here's assign equals expression, then ignore. So there's variable def, but then there's also just plain assignment. Expression, assignment. Wait a second. Assignment should be higher precedent than expression, because expression is more general than it. In fact, I think since expression is the most general out of all of these, it should be last. Okay, I'm confused. So I have an expression. It's expecting. Here it fails. What is expecting? White space, line comment, block comment. Expression. Here's token star underneath atom expression. Right here, this should be a valid expression. I'm going to unlabel this so I can get the full list of things that it's expecting. Come on. Please, parser, just work. Okay, was expecting a white space, line comment, block comment, opening parentheses, number, whatever this is, true, false, tuple expression, struct expression, identifier, period, or a comma. Oh, because this is potentially a tuple. What did you accomplish with this stream? I have implemented everything. As far as I know, I've implemented everything I've needed to actually run this benchmark code, which runs this while loop 1 billion times, or runs this code 1 billion times while editing a slice. The only problem is the parser isn't working, and like I really think the parser is the last thing needed to get this working. And the parser is not working. Wait a sec. Add prompt. No, that's a giant match statement. Quick Rust. Why are you using scripting language again? Sandboxing. Runtime loading of untrusted code. I've had a problem in the past where sometimes choice blocks are too big. What is this? Number is expecting everything, literally everything, but you can't use Rust as a sandbox scripting language. It compiles directly to a binary. The point of Brane script is it works similar to like a web browser, but in VR. And for a situation like that, where you will be downloading code that other people wrote, and you don't necessarily trust all those people, if this coding language isn't properly sandboxed, they'll be able to... No, it's not interpreted instead. The point of writing my own scripting language is that it's not interpreted. It's sandboxed in the sense that it is as sandboxed as an interpreted language could be, but it's JIT compiled all the way to machine code, so it's significantly faster than an interpreted language. And I could do that with WebAssembly, kind of, sort of, but WebAssembly isn't good enough. WebAssembly is the closest thing to what I've made. So if you go watch a video about all the benefits of WebAssembly, those basically apply to this, except for the you can compile any language you want to WebAssembly. No, with BraneScript, it's just BraneScript. How's it sandboxed then? Can't people modify the compiler to make malicious code? No, because the compiler lives on your machine. They can't touch it. And then the intermediate representation, the thing that your compiler actually compiles, can't, because of the way I wrote it, it can't represent malicious code. Unless, like, my APIs are leaky, but it can't directly access stuff. Yes, it compiles after the world is downloaded. Why is it broken? Yeah. I'm gonna put that right at the beginning, so it's like, hey, compile this. It's literally the first option. And if I check this, did it say that it's looking for path? Identifier, I think identifier is part of path. Let's see path. Did I label path as path? No, so identifier would be what it is. So it's literally just that that this was too long or something? I don't know. Oh wait, this is type. Doesn't that fix that? I'm also going to move this up to the top too, just in case. In the future, we run into issues with the same one. Was expecting a white space, line comment. Ah, this one actually is on me. We don't have any operators, so this needs to be add this and that. I want this to not be a tuple or scoped. Failed to resolve path segment, I-32. In where? Wait a second. Path, I-32. I think I know what's wrong here. By the way, that means it fully parsed it. So now we're back in librs. Path. I don't see anywhere that I-32 should be an identifier, but failed to resolve path segment here. Okay, I make fancy error. Failed to resolve path segment, I-32. We're gonna fancy error this because I need it. error at then we emit this. Reference to self emitter. Yeah, that's close enough. Okay, and now we'll be able to actually figure out when that gets triggered. There we go, add test I32 cannot resolve segment. So we can't resolve it inside of type, which means native type is getting put after... Where are you, parser? Oh, a native type always needs to be above path. Override for slice I32. That's right, because it should be unsigned in 32. My thing is working. One second. I want to update my error to include no override for... Path should have arguments. Do I parse? Okay, we check path to see if path display shows it doesn't. So the code is wrong. Okay, there we go. Now I have slice I32, I32. And this should be U32. And because Index is going to complain that it's not being given a U32, I'm going to change all of our types here to U32 out of safety. Just because I don't have casting yet, and I do not want, at 10 hours into the stream, I don't want to have to switch to implementing casting. Slice length must be U32 value. I'm gonna check the parser. U32, U64. That looks correct. Okay. Next, we check the const U32. U32. So we have a literal kind U32. IR native type U32. Oh, I'm checking the pointer. I want to check length to make sure it's U32 sized. Expected struct 1, but found struct 0. Pointer length. I wish I had actual display for this. That would make it a lot easier to figure out what is going on. Here we go, slice, emit type. Actually, if I put this debug code directly into slice type there. Please work. I do not have the self-control to stop until this works, so I am trapped here until it does work. It is struct anonymous pointer moot I32 U32. Wait a second. Is this me doing a dumb? It is me doing a dumb. See, if I had actually taken the time, to do proper errors for everything, I'd be getting nice debug messages like, oh, expected slice of this type found. This type, oh no. Override type for greater than I32 and then that. Aha! I love when my compiler gives me understandable errors. While condition must be a bool, but was I32. I know where this is a problem. This is a problem in intrinsics. We're making progress, though. That's a crazy thing. We're making progress. Compare type and find binary operator. Okay, it doesn't need this. So basically what was going on was my helper function for all of these assumes that the return type is exactly the same as both of the arguments. But in the case of comparisons, it doesn't care. It always returns a Boolean, so I need to have a way for my little helper function to have an overwritable return type, basically, is what I just did. And I just edited all of those and put it in the wrong order. It actually needs to go after the types. Fortunate, because now this is a lot messier. No override for I add. Integer to 32. 32. Where? U32, U32. 32, U32. Where is he? Is this it? We add pointer and remainder. Why is U32 on the left if it's the pointer? Because remainder should return U32. Here, I'm swapping this to... Self-compile context. Wait, no, yeah, that is correct. Nearly 10 hours, it's 9:54 of uptime. Path has a span, yeah. Okay, it is that. I find it very peculiar that the arguments are out of order. That's a problem with the parser. But also that okay, where's I referenced? So if we change I to I32, and R also to I32, then we don't need to implement casting. I am concerned that the arguments are in the wrong order, though. That is, potentially very dangerous. Yep, there is no way that that could be out of order. Wait a second, we're dereferencing index. This is a slice of U32. So that is U32. And remainder of J and U. Maybe it's a problem with remainder? Remainder should still be returning I32. This is correct. Actually. Remainder might be wrong. That AU pointers as U32 or I32? I don't remember. In any case, we index by U32. So this needs to be U32, U32, U32. Back to this. Adding index, which this is correct. Remainder, it doesn't seem to be correct. So if we go to intrinsics, remainder for signed, remainder for unsigned. Wait a second. This wasn't even doing what I thought it was doing. No, we need to actually return... unwrap or else type clone. The actual argument type should be the same, but it was hard-coded to I32 for all of our operators. We are so close. Okay. We got to the JIT compiler, guys. I repeat, we got to the JIT compiler. And we got a not implemented on line 156, which is I multiple. How did I miss that? Well, it's because I used the instruction and didn't realize I had. We're using this for the index operator. So that is the last thing required. Ooh. Caused by verifier errors. Let's type I32 expected I64. I add type I32 expected or arg1 v28, which is the second argument. Is type I32 expected I64. So basically, what this is saying is, I think it's in our store and load operations. It has to be in our store and load operations. That would be in binding and load. Okay, so we have two readings of the values and one setting of the value, which means we have 3 total times that we access pointers, and we get this error 4 times. Not 4 times, 6 times. 6 times means it's these load and store operations. Meaning that I add the bindings offset, let bindings offset equal context builder instruction Brane lift, cast, I-32 to I-64. Extend. Right, that's what I expected, but... Okay, instruction builder. So we have U extend, S extend. Okay, we want unsigned extend. To types. I-64 from the 16-bit to the 64-bit. We need to do this on this binding offset as well. We need to do it for this offset as well. It's running. It's running. It's taking a little bit. It's taking a hot minute. Oh. It's because I'm adding 1 to our I was adding 0 to the indices. There we go. Okay. Status access violation. What is a status access violation? Attempted to access memory that it was not authorized to access. This form of memory access violation, often leading to a program crash or unexpected behavior. This isn't supposed to be possible. Like, straight up, not supposed to be possible. And it happened after a little bit, meaning that, it's when we overflow the register. When U32 gets larger than Status access violation. Status access violation. That's pointer bytes, not pointer bits. Pointer bytes. Shift left 16. Did I do this incorrectly? In either case, it shouldn't be able to access that. Binding, offset, right, because this is max value. Okay. Yeah. Zero extended 64-bit immediate constant. If I add one more, it should error. No. No, wait, zero extension should add to that side of it, not to this side of it. I think I want... the bit shift left. I think I want shift right. And now I know that I had this working. Because this is supposed to take the top digits of the pointer and then shift them down. feel like this should not have been able to get out of bounds even with this. Wait a second. This might be wrong. I haven't tested this. Okay. Wait. Yeah, no. Use 2 of these for 1 byte. So this would be 1, 2, 3, 4, 5, 6, 7, 8. And that's the entirety of it. Yeah. Because this can only represent 16 possible values. So the 2 of them together is 256, which is a byte. So these are 2 bytes. Times 2, yeah. I think shift right is correct here, though. Old version that was working used shift left. Then again, that got a status access violation immediately. Bit and .40 is I add I32. I shift left. Wait a second, this is store. I didn't change it on. Wait. Unsigned. Signed bit is the last bit. That actually would be assigned. And do we want this to be unsigned? Because otherwise it would keep that top bit there. Guys, we have a result. I don't know if it's correct, but we have a result. What did our function return? 999. I have no clue how to tell if the test result is correct, but this is significantly faster. This is significantly faster than the test I did before that was incorrect, so I don't know what's going on. It's like making the program is 10,000 times 10,000 equals 1 billion, right? No. 100 million, which is nowhere close to it, which means I didn't read the source code right, because dyslexia or something. Also, I love how the version that circulates all around online has C being faster than Rust, but now its Rust is faster than C. Okay, so if we look at loops, C, run C, is this even 10 billion? Or 1 billion? Okay, so we have 10,000, 10,000. Okay. 10k times 10k. Am I tripping, or is this benchmark flawed? Let's see the rust. Where's the rust? Maybe I'm misunderstanding something with the C version of this. So here's the loops. Where are we getting loops from? Loops. Using the loops crate. There it is. Iterations outer, iterations inner. For each element in the array, which is 10k. Let me just see, let iterations. And then in here, If this is functioning correctly, we'll return 1 billion, I think. Oh, and I should update source to have this return unsigned stuff. Oh, did it run? Yeah, this is 100. Am I supposed to run this loop 10 times? That's what's going on? Loops outer, loops inner. 100,000 inner loop. Okay, that makes a lot more sense. Let me see. Check the C again, because maybe I'm just literally blind and it is 100 inner loop iterations. 100k. No, it's 100k, 100k, and then benchmark run loops. Benchmark result value number 2. That's 10k and 10k. That's not 10k and 100k. The C benchmark. Is C cheating? Any case, yeah, loops outer 100k or 10k, loops inner 100k. Iterations outer, which is 10k, iterations inner, which is 100k. So I'm gonna copy the Rust one, because obviously Rust isn't cheating, but C is. And now we should get a benchmark result that is more in line with the other languages instead of like, oh, my language is significantly faster than C. No. Okay. This is a much more expected result. Look at that. My scripting language takes a second, about a second and a fourth, 1.25 seconds-ish. Which, if we look at this, that puts us right in the, okay, no, it doesn't make us slower than than PHP, but it puts us at right between Dino and Julia, so we aren't as fast as Lua or JavaScript. We are actually slower than JavaScript. Oh no! We are slower than JavaScript, but that's because we don't have SIMD optimizations and whatnot. if we did have SIMD optimizations, this would go as fast as we could make this as fast as C if we have SIMD optimizations. But we don't have SIMD optimizations. It makes me sad that it says it's not faster than JavaScript. Then again, this is like not a in runtime benchmark. Like, we will make up for it. We will very much make up for it over the long term. Oh yeah, there we go. That is benchmarking Brane script to be slower than Fluidshit and Node. Yes, so it's JIT compiled. So we are like straight up running assembly. So you can see in my testing code here, right here, you can see I literally standard mem transmute. So this is a raw pointer cast to a function pointer. And then we literally just run that JITted function pointer. Yes. So I'm not doing it just in time, which is what JIT is like named after, is just in time compilation, which is usually after a function is expensive, then you JIT compile it. Instead, what I'm doing is just everything is JITted from the start, and it's not that expensive. Like, the entirety of compilation takes 14 milliseconds. That's like 2 frames, 144 FPS, but if you put that on a background thread, it's fine. This is also probably taking into account actual parsing. Parsing is probably slower than actually JITting this. That's actually a good thing to benchmark. I'm gonna add that into the benchmark. So instead of this being compile start, this is going to be parse start. Actually, that would be compile start. And then this would be JIT start. So we'd say here compile start, or rather JIT start minus compile start. And then here we'd say full program took end minus compile start. Here. Let's see, where does compile time? Compile time is now minus compile start. So this is actually git end. Compile start. Actually, this would be git start minus compile start. That would get us the time it took to compile, and then git start minus, no, start minus git start, and then full program took function end minus compile start. There we go. So now we should be able to see how long JIT compilation takes. So yeah, the jitting takes 6 milliseconds, so it's basically free. Not free, but it's pretty fast. If we have this on like asynchronously compiling in the background, it would not take too long to compile stuff. And I bet a lot of this is startup costs rather than actual, well, we can even try this in a release build. And that won't make my stuff run faster because my stuff doesn't have optimization flags and it's being directly JIT compiled. So, yeah. Okay, and now I really want to add SIMD optimization passes to this because, yeah, I really want to add SIMD optimization passes to this so that I can put it right next to like an actually compiled language. Well, it's still faster than Udon. It's still faster than Udon. I can't act smug on TikTok, though. Because it's slower. It is, in fact, slower. I wonder? Does crane lift add in checks? No, I'm wondering. To manually detect it for now, there are instructions like I add continued. Oh, wait. I don't use JIT end. Means I might be including constructing the stack inside of jitting, and constructing the stack, this actually takes a fair amount of time. So jitting might take less than 6 milliseconds. Then again, that was a release build, so I don't know. Dang it, now I'm going to be the one going, oh, these benchmarks don't actually reflect real-world, they don't reflect real-world performance. Yeah, see, JIT actually takes 2 milliseconds. Free. 2 milliseconds for the price of running a billion billions of nested loop iterations, and it only taking a second. It could be faster. It could be 1/4 of this. We could be using SIMD. We could be using SIMD. Alright, I need to wind it down because I actually have to. I'm gonna pop melatonin right now. So I'm going places tomorrow. Alright, well, we got the thing working. Let me actually print this. Or not print it, push this. And yeah, we have 1 billion nested loop iterations. And now I'm gonna make this officially the main branch of BraneScript, so yeah. And as long as pointer operations are working correctly, this should be a fully functioning scripting language. We can use this for whatever. SIMD. I need to add SIMD. I didn't think I needed to add SIMD, but like, to reclaim my honor of having my scripting language be faster than JavaScript, I need to add SIMD. Or else this will drive me insane. Alright. Good stream. Goodbye.